Three resistors.
We have what's it called? This is not the box, yeah. The same one as the power transfer.
No, this is not power transfer. This is Kirchhoff's.
Culture? No, no. I mean this box because it looks like it's the similar one.
No, this looks similar to RC circuit.
I mean it's a RC circuit. My bad. So this
Yeah,
is a
no, it's
different
different.
one. This is a whole ass different
It's
one.
different. It's different. Look at the shape. It's different.
Mm-hmm.
Yeah.
Okay.
It looks same, but it's different.
Wait, let me just draw it quickly on the book.
And
Okay,
this
so
one looks like a this one looks like a Y shape. That one looks
X
like
shape.
a rose and columns.
Oh, so this is experiment 6, yeah? Culture's law.
I don't know the number.
I think I wrote it down here. In the thing, yeah, experiment 6, culture's law.
Yeah.
X6, Kirchhoff's law. Okay.
Always use the help of the circuit diagram. It helps a lot.
Hmm?
So you know which connections are. That's very important.
Yeah, that's the thing. I don't really understand it. I will show. I will put this in the screen here,
Okay.
so you
Put a
can see.
circuit diagram. I'll explain it to you. Open a
Okay.
circuit diagram on the screen. I'll explain it to you.
Like for example, we are doing culture's law. Yeah.
Yeah, just open the circuit diagram. I'll explain it to you. Yeah, okay. Fine. So you see how there's three dots?
Yeah, like here.
Yeah, yeah, correct. So you see the dot in the middle?
Yeah, this one.
Yeah, so that dot is called the junction. Okay, keep that in mind.
Hmm.
Alright, so in the junction point, you can see that I1, I1,
Hmm.
I2, and I3 they both converge. So I1 comes from the R1, and I2 comes from the R2, and I3 leaves the junction point. Do you understand?
It goes like by itself.
Yes. So there's a Kirchhoff's law that is called basically current entering the junction is equal to current leaving the junction.
Hmm.
So you tell me what current is entering this junction and what current is exiting the junction.
R1 and R2 are entering.
Not R1, I1. I
I mean,
said current.
I mean, their point they made what they created I1 and I2, yeah,
Yes.
and then I3 left the junction.
So what is the formula?
Isn't it like the same as we did? It's like
Remember what I remember what we did for
I1
physics
plus
too?
I1 plus I2 equal
Yeah.
not equal I3 like minus I3 something
Yes, good. Is equal to?
equal to I3
No, it's equal to zero. I1?
minus I3 equal to
Yes, correct. Very good. Alright. Now next thing you have to remember is I'm not done. Wait.
no. I'm just looking at the thing we
Okay.
did.
The next rule that you have to remember is do you see that circuit on the right?
Is this one here?
Yes. Do you see there are two boxes in the circuit?
Yeah, here
The
and
left
here.
the right box and the
Minus and
left
plus.
box. No, no, listen. Do you see the right there's two circuits. Can you see?
Bro, wait!
There's
I just
one on the
realized
left.
he took 0.5 marks. It could have
Forget
been 9. My bad. It could have been 9, but he took it just because I didn't put two arrows.
yeah.
Bro, really, look.
Shit. Yeah, shit.
No way he took.
Alright, fine, listen.
Yeah, okay.
Alright. Do you see the line in the middle?
Mm,
Like the line that coming in the middle of the circuit?
yeah.
Which makes the circuit into two separate boxes.
Mm,
Alright. So that point is called a junction. So that is what makes the circuit on the right,
mm,
different from the circuit to the left. So when you take one loop, for example, uh, the loop in the VS1 side, okay, like the left
mm.
side,
Okay.
right? In that, whenever you take it, according to Kirchhoff's loop rule, it says that the total voltage in the loop is equal to zero. Okay, so that's the voltage rule. So now if you take the voltage like what are the three voltage sources in that loop? Say for example the VS1
R1,
loop.
R2, and VS1. We have one
Yes,
V1 and R3.
very good. So VS1, R1, and R3, right?
Hmm.
Correct. So now if I'm going from the positive terminal to the negative terminal, so I'm going from R1 to R3 and all the way back to VS1,
Hmm.
then what will my formula be?
R1 plus R3.
No, I
Uh,
said I said voltage. R1 is resistance. So what will
oh,
you how will you get voltage?
isn't voltage? We'll put it in the what's it called? Voltage is equal to IR. I over
Correct.
R.
So what would it be? What would the voltage at R1 be?
Not R1. R1 is I1.
Correct. What is your current through that R1? I1 or I2?
I3.
Current through R1, not R3.
Through R1, I get I1.
Very good.
But
So what is the voltage there?
I1.
I voltage, not current.
Oh, voltage, you mean at like that point?
Yeah,
It's
at R1.
VS, yeah?
No, at R1, at R1. See,
R1, I
whenever
get
you reach,
I1, here, yeah, I1, okay.
whenever you reach a resistor or a capacitor, right, you will
Yeah.
have a potential drop, you will have a voltage drop.
Hmm,
So the voltage at the resistor will be different than the voltage for the circuit. Say for example VS1, right?
hmm,
VS1 is voltage, okay, but when that voltage reaches the R1 resistor,
hmm.
the voltage will drop and it will cause a different voltage value. So what is that voltage value is what I'm asking you.
Okay. So we need to find the voltage because it will go like from here
Very good.
to here,
Yes.
then back here again.
So let me explain this to you, okay? The
Okay.
current the current going through resistor 1 R1
Yeah.
is equal to I1. Do you agree with that?
Yeah, because at
Because
R1 we get I1.
correct. So what is the formula for voltage? I into R, correct?
Hmm,
So now we know the current, that is I1,
hmm.
and we know the R, which is R1. So what is the voltage? I1 into R1. Simple.
I1 into R1.
Yeah. Okay. Now tell me the
I1,
same thing.
this I1 is into R1.
Yes, correct.
So
Good.
how do I write it? I write it like, wait.
No, no, let me finish, then you write it.
Hmm.
Okay.
No, no, I mean,
Now you
how,
tell me.
yeah.
Now you tell me. What is the voltage at R3?
R3 here,
Yes,
it's
there.
I3.
I said voltage, not current.
Voltage, you mean? The
Yes.
VS.
What is the formula for voltage?
Didn't we say just I over R?
I into R, not I over R.
I mean, I times R.
Yes, I times R.
Okay, so for
So
this
what
one,
is
it
I?
was
What
what
is
R?
R?
What's its R? Yeah, no, what's its R? Because we know, as you said first in the beginning, the one that's in, going in is I1 and I2. And one that's
Yes.
out is I3.
Yes, good.
Hmm.
So what
And
is the I over here?
VI,
For R3?
V1. Hmm?
What is the current going through resistor 3?
The current going to resistor 3?
Yes, what is the
I3.
current? Very good. So what is the voltage then?
Then it will be I times R. So I3
What is
times R3.
very good. Excellent. So now you know the voltage on R1 and voltage on R3. And
Yeah.
you know the voltage on VS1, which is VS1.
Hmm.
Correct?
Hmm.
So what will be the formula
For what? For this one, you mean? This one and this one?
for for the loop rule?
The loop rule. This is the question in the midterm we got.
Yeah, okay, let me explain that to you. So loop rule, like I said, is the place where sum of all the voltages in that loop is equal to zero. Okay?
Hmm.
So in this case, we got the voltage at R1. What is the voltage at R1? I1 R1.
Your
Right?
voice just lagged.
What is the voltage at
Your voice
R3?
lagged for 3 seconds.
I3
What did you
R3.
say?
Huh?
Your voice lagged for
Okay.
3 seconds. What did you say?
So did you hear what I said about the voltage rule?
No, no, your voice lagged and before you
Okay,
even said it.
okay. Okay, so okay, listen carefully, okay? So the voltage loop rule is when the total sum of all the voltage in the loop is equal to zero.
Hmm.
Okay? So in this case, we have three separate voltages. What are they? The voltage at R1, the voltage at R3, and the voltage at Vs1, which is equal to Vs1.
Mm.
Correct? So now, if I want to sum all the voltages up, what will the formula be equal to?
If we bring them all together, yeah.
Yeah, tell me.
Want it to be like first we have our I1 and I2 minus I3, yeah?
Yeah, I didn't ask about the current rule. I'm
Mm.
talking about the loop rule. I just told it to you right now, right? What
Mm.
is it?
Wait, isn't it like.
Okay, okay, wait, Rashid, pay attention, okay? So look, there is a voltage drop at R1, correct?
Can I bring all the loops? I mean, not all the voltages?
Okay, do
Are
one
they
thing,
not
do one
equal
thing.
to zero?
Do what I'm saying, okay? Do what I'm
Okay.
saying.
Mm-hmm.
Take take a mouse and then draw a circle around that loop so I can explain it to you because I cannot draw.
Wait. Well, can you share screen for this?
Yeah, okay, but I'm on my phone. How can I share?
Oh, you're on your phone?
Yeah.
Oh, my bad.
Or I can maybe share like paint or something, yeah?
What happened to your, what's it called? Laptop? You don't have it?
Laptop is on charge. It's charging.
My bad.
So wait, should I share my paint thing from here? Does it work?
Okay, so this
Let
one,
me
yeah?
try sharing. Wait, let me
This one.
try sharing.
This one, I mean. Here, check. This guy and this guy.
No, 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 wrong, wrong.
What?
Let me try sharing. You can
No, no,
understand.
I am. Don't you see my screen?
No, no, let me try to share so I can draw it for you to explain.
Okay, sure. Bro, you know what I think I should do? I have
Yeah.
an idea first before I do any
What,
of that. Let's not waste time. You know what I will do? Wait, let
what,
me stop just
what
gang. I want to do this way first.
can you see what I'm writing?
Yeah, okay, fine. You do what you want to show me quickly.
What do
Yeah.
you want to show?
What you want? No, first you do what you want to do. I want to finish
How
that,
do
and
I
then I
clear
will.
all this?
Press on
Okay,
clear.
one. Okay, look. Remember I told you there was a circuit, right? So this is a circuit, okay?
Yeah.
This is the battery.
Yeah.
Okay, this is the resistor, R1.
Mm.
Okay, this is the first half, okay? This is the R3,
Mm.
okay? And okay, this is the rest of the circuit. I'm not drawing that, okay?
Mm-hmm.
I'm not drawing that. I'm just going to leave it there,
Mm.
okay? So over here, you know that
VS1,
this is
R1,
R1.
and this is
This is
R
R1.
R3.
This is R3. And this is Vs1.
Mm.
The voltage over here is Vs1. We already know that. Okay. Now what Kirchhoff's rule says is the total sum of the voltage in this particular loop. By this loop, I mean this loop. Can you see the arrow?
Mm.
This loop is equal to 0. Okay, that's the law. Alright. So we know what current goes through this one, I1. Correct?
Mm.
We know what current goes through R3, I3. Correct?
Mm.
So now all I have to do is find out the total voltage. Now I know the voltage over here is I1 into R1.
Mm.
Over here it is I3 into what?
Yeah.
What?
I1 into I3 in this case, right?
No, I3 into R3 because it's I3 over here. Look,
Yeah, I3 into what?
what is this?
This one R3, yeah.
Correct.
I3 times R3.
Yeah. So now I'm going to add all the voltages up. What is the first voltage? Vs1. Okay,
Mm.
Vs1 plus. What is the second voltage?
Second
Minus
what?
I1 R1.
I1 R1.
Okay,
Mm.
plus again minus what? I3.
I3 and R3.
You know why I'm taking minus?
Because it's like going oppositely.
Correct. Because the current, even though the current is going like this, the charge is moving in the opposite direction.
Mm.
Alright? So that's why I'm taking it in the negative. All you have to remember is it's because I'm going from a lower potential to higher potential. That's sorry, higher potential to lower potential. That's why. Okay?
Yeah,
So this is equal to zero. Understand what I'm saying? So
yeah.
this is the final equation. Let me write it down. Vs1 final equation minus I1 R1 minus I3 R3 is equal to 0. So this is the final equation. This will come for the exam. You should not forget this.
VSI is equal to minus I1 I RI equal to I3 and I and L3 R3. Okay,
Yes, correct.
okay,
You understand this? Do you have any doubts? You can ask me.
okay. View box but wait.
Do you have any doubts?
I'm just understanding the thing. Okay, I think I
Mhm.
can write it down now. Wait, can you look at my screen? Okay.
Yeah,
Okay.
you can write it down now.
How long can you stay today? So I don't waste your time.
I can say however long it takes for you to learn. Right.
Okay, well, thank you very much. Okay,
Go, 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 go.
okay. Let's.
Yeah,
I want to watch this video, and then the other two,
yeah.
and then what will I do? Is I will just I will just redo each lab. We'll just redo
Okay.
each lab, but using my data that I got.
Yeah,
So
okay.
this lab, for example, this I have here. Yeah. I
Yeah.
will do this, and I will just download
Learn how
the.
to do the connections. Learn how to do the
Yeah,
connections.
yeah. No, I'm going to do that. Yeah.
Yeah.
Okay. And what
What's
did I tell
tracking?
you about the connection? The connection is like 40% of the exam, or like something like this.
Not 40%. I would say if you cannot do the connections, then you cannot get the values, and so then you cannot do the whole lab. So I would say connection is 100%.
Hmm.
The connections are very important. Otherwise, you cannot even start the experiment.
Yeah, you're right. Okay.
Yeah.
Okay.
Three resistors. In the second part, we have one power supply and four resistors. So for the first part, let's do our connections.
So I have this box. I will just go. What's this called? That one? Or there is no name
Which
for it.
one? Which one?
This one. This guy. One, two, three, four, five, six, seven, eight, nine.
That
Okay,
is
just
the
call it
circuit.
1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9, and the power transfer has like no, not power transfer. RC circuit has like 12. So this is different. Okay. This guy, this guy, this guy, this one here, this one here, this one here. Okay. Okay. And we have two multimeters, yeah?
Yes. Two
Two
multimeters.
and
One will be
three.
used as a voltmeter and one will be used as an ammeter.
Mm-hmm. We have two multimeters. And we'll also use the load or no need in this?
Yes, yes, you'll have. No, no,
Okay.
no.
Huh?
This time you don't need it.
Hmm?
No, I don't think you need it for this.
Okay.
First step is to have our circuit diagram as it is, and then later on we'll have our voltmeters and ammeters.
This is like the circuit diagram as you said. Yeah, this is like R1 here. Let me
Yeah,
show my
correct.
screen. This is like R1, and this is
Yes,
R3. This is like it's
yes,
I3 under, and this is like I1, and this
very
is
good.
like where the charge, like the
Yes, good.
VS1, and this is like the same thing here, R2, and this is VS2.
Yes, very good.
Okay.
To verify the Kirchhoff rule. Of course,
Can you
again,
hear
I'm
it also?
Yeah, I can
repeating
hear.
this. Go back to your lab
Doesn't
reports,
matter if
see
I
how
can
the
hear. You should hear.
derivations were, how you got the voltage equations for the voltage loops and the current equations, so depending on how you had set that up. But for the circuit diagram, I will, let's say, take some wires. Let me just quickly take three small wires to. Alright, I have R1, R2, R3. There's a connection already here.
Yeah, R1, R2, and R3.
Yeah.
Okay.
So just take a wire from R1 to this junction point.
Watch
R1,
carefully.
yeah, R1 to junction point. Okay.
Yes.
So yeah, okay. So wire here. Let me just draw it. Okay, so a wire from here to here
What time is your lab tomorrow?
at like 3:30.
The final?
Yeah.
Hmm. You have time.
Okay, and then okay. So this is first wire.
Take another wire from R2.
R1. And then we'll take this one R2. We'll also put it above it, I think. Yeah.
To this junction
Yeah.
Yes,
Okay.
correct.
Okay.
point, and then you have this another
Okay. Third one we'll put it here. No, I mean here.
No, no.
small wire
The red one.
to this
Yeah.
Yeah.
R
Okay. So yeah. Then another wire to here. Okay.
3. Okay, connect this place here for your first power supply, VS1. This place here for your VS2.
We have two power supplies, or this is the mode? Well,
So
We have
let's
two
connect
power
VS1. So
supplies.
this is my
Remember
VS1.
VS1 and VS2? VS1
okay.
is one power supply, VS2 is another power supply. Remember I
Yeah,
told
yeah,
you it's
okay.
separated into two halves?
So two
Yeah.
power supplies, okay.
Yeah.
Positive goes here.
Okay, so we'll just write the power supply.
Remember the
Uh,
positive end should go to the top and the negative end should go to the bottom. That's
yeah.
very important.
A,
Look, you see
V.
the positive sign on the power
Hmm.
source? You see the positive source?
This one you mean,
See
yeah?
where the positive is connected. Yes, correct. That's the positive end.
Mm-hmm.
That should always go to the first one. And then the negative end should go to the black one, the bottom one.
Wait, the middle one is division, yeah?
Huh?
The
No,
middle
no,
one,
I
the
told you,
minus?
forget the middle one.
Yeah, okay,
Only
no, no, I'm
minus
just,
and plus.
yeah, I'm just like to write it. Okay. So this is the same thing. Plus, okay. So first, yeah, on the first port here, it will be like what? Plus power to the power supply, positive power supply.
Yeah, correct.
Okay. Then
And
another wire,
the
And
the negative.
negative goes here.
Okay.
This is
So this negative
don't forget
to
the
this one.
connectors, which is the positive, which is negative. You'll have the circuit diagram, but still don't make the mistake, okay?
my VS1.
I will make it exactly like this.
Out VS2
Hmm.
positive
To the corner.
goes here.
Okay, so positive to this one, and the negative will also be the one under it exactly. Okay.
Yeah.
And
The one negative, it will be here.
is connected here. So this is my VS2. This is the starting point. Three
You understand
resistors,
now
two power
clearly?
supplies. All I have to do is
This
get
is the
my
only wiring.
different
Correct.
voltages and
No,
the
no, no.
current
Now they
information.
have
So
to
and then
connect
I
the
have to verify the
ammeters.
equations which I had
For,
derived in the
the only
lab.
wiring for power supply.
For the voltages, I will have my
Yeah.
voltmeter. So I will take the V terminal.
So pause
This
the
is the
video. Let me
positive
explain
one.
something.
Okay. So this is
Okay, remember
nice.
I told you, remember I gave you the formula? Right now, BS1 minus I1 R1
Hmm.
minus I1 I2 R3. I3 R3 is equal to 0.
You're saying because basically VS1 is equal to what? To
No, no, listen what I'm saying.
mm-hmm.
So in order to find the value of all the VS1, V1, V2,
Hmm.
V3, all of those values, you're going to put an voltmeter on top of all of these. For voltmeter, you always connect it in parallel with the resistor. Okay, but when you're doing it with an ammeter, you should do it in series. I think you learned this, yeah? You know this.
In series, there is like two ways,
Okay.
parallel and in series.
Yeah.
But this one
So
is in
whenever you
series.
have to get a reading of a voltmeter from
Yeah.
the voltage, you always connect it in parallel with that circuit. Okay. But okay, let me explain it to you. Stop
Because
sharing.
in series it's different.
Let me explain.
Yeah.
Can you see my screen?
Yeah, sure.
Okay. Do you see this resistor over here? Do you see what I'm drawing?
I see it. Yeah.
Okay. Do you see what I'm drawing now?
Yeah.
Okay. Let's say this is a resistor. Okay.
Yeah.
And this is a circuit. Uh, all right. Let's just say this is R1.
Hmm.
Okay. Now I want to find, and let's say the current going through this is I1. Okay. Now I want to find what is the voltage on top on this resistor over here. Okay. I want to know what is the voltage in between this resistor over here.
Won't I
You
make
understand
it
what I'm saying?
what's it called? I into R?
Yes,
Uh,
correct. That I have know. But I want to know the exact value. So I want to check, right? So what will I do? I will take my voltmeter, okay?
hmm.
Voltmeter, okay? And I will connect it in parallel with this R. So take for example this, okay?
Hmm.
This is my voltmeter. So I'll connect
Okay.
it in parallel with my R. Look,
Yeah.
I would, you know what the definition of parallel is, right? Look, it's
Yeah. Yeah.
opposite to the R, opposite to this. You see?
Yeah. Yeah. Okay.
That's called parallel. Okay.
Mm-hmm.
So this is how whenever you want to find the voltmeter reading, this will give you the voltage. The value on this will give you the voltage.
On the
Okay?
multimeter.
Yeah, on the multimeter. You have to set it to a voltmeter reading though.
Yeah. Yeah.
Now,
So the other part.
if I want to find the current, then I will use an ammeter. Okay, ammeter.
Is the
I'll show you
first
how to connect
first or
that.
second
So yeah,
first or second port, and the com is the third port, and the fourth port is the voltmeter. Yeah.
I'm not sure about the order, but yeah, it will be given on the sign. Don't worry. Okay.
Okay.
Look, now let me explain you how to connect the ammeter. So this
First, I
is
make it into
another.
an ammeter. I bring just a wire. Let's just say I bring a wire. I put it on the ammeter, and then what?
Yes. So now I have a circuit, right?
You have a
Positive,
circuit. Okay.
negative. But now I want to connect this. I want to find the current over here. Okay. I want to find the value of the current. How do I do that? I use an ammeter. Okay. Ammeter.
Ammeter. So
All
first,
right.
this is gonna be on the first multimeter.
Yeah, correct. So how am I going to do this? Last time I took it in parallel like this.
Hmm.
That's wrong. Okay, don't do that. This
Yeah, I
time,
know.
what
I
you
was
do is,
confused because you were talking about series and you changed it to parallel.
uh, so now you take the ammeter in series with the resistor. So whatever current you get over here, whatever current you get over here,
Yeah.
that will be the current going through R1. Is it clear?
Mm-hmm.
Yeah. Okay, that's it.
Okay. Okay. So I to R1 to A, and this is our ammeter. Okay.
Did you understand what I said?
It's a bit confusing, bro. That's my thing. Okay, because we added the series one, yeah, to make it
Yeah.
like from we could add our multi not our multimeter at a meter ammeter I mean, and
Yeah.
then we'll plug it into what into the one next to the resistor, yeah, between the charge and the resistor. I mean between the
Yes.
resistor and the VSI.
Correct.
Hmm. Okay,
Did
so
you
the
understand what I taught you right now, or you want me to explain more?
can you just like simplify it?
Yeah. Okay. I'll explain. All right. Okay. Do you see? Do you know what a circuit is?
Yes,
What is a
I know
circuit?
the circuit. I want you to draw it. I3,
Yeah.
I1, I2.
You tell me
Okay.
what to draw. I will draw.
Okay,
Because
just draw
that will.
first. Let's just make it like the what's it called? The experiment itself. So like make the battery basically this guy plus and minus.
Okay.
Yeah. And then on the upper line, so make like a straight line. Then the resistor.
Okay.
Okay. Then like go down, and then I call this
Yeah.
I for example. This is where our I
Okay.
is. Like we'll put a junction here. Okay.
This is where I1 is.
No, no, this is R1.
Okay.
R1, and this is what's it called I1 down.
Excuse me.
No problem. Allah.
Yeah. Go on.
Bless you. R1.
Mhm. I have a lot of allergies in my room, bro.
It's okay, bro.
It's okay. Go on. Go
Okay.
on.
I1
Where do you want me to put I1?
on the right.
Over
For
here.
the point, yeah. But it's all going in. Okay,
Okay.
then just like connect it back to the thing. Yeah.
Okay. Good. So you know this is a closed circuit, right? Because
Yeah.
it is closed. All right. So in this, if I want to find the voltage on my R1, how would I do it?
The voltage on my R1.
Yes.
Okay, so the equation first is like V is equal to I into R, yeah?
Correct.
But we don't know what's our R1, yeah?
Yes.
Okay, so I will
No, no,
bring.
we know what is R1. We
Oh,
know what
we
is
know
R1.
it. Yeah, but how?
Yeah.
Why do you want to find it if you already know it?
No, like
I
the
mean,
exact value, like the
oh,
experimental value.
exact value. Then, like our experimental value versus real. This is okay. I know
Yeah,
what you
yeah.
mean.
Correct, correct.
Okay, so basically we bring the multimeter.
Very good.
Put
Okay.
it on the amp meter, like the second port, I think, or the first one. They say doesn't matter. And then for safety, first we'll make it into a voltage. Yeah, not voltage. I
Okay.
mean, we want to know the voltage. Yeah.
Yeah.
So we'll take the multimeter and make it into won't we use the voltage part of the multimeter?
Volt?
No, no, there's two parts of we have two multimeters, yeah?
Yeah.
One is an ammeter and one is a voltage meter.
Yes, correct.
Okay, so which one will take?
You tell me. I want the voltage.
You want the voltage and I will take the
Very
voltmeter.
good.
Okay,
Very
so I will
good.
take the second one, I will put it on like the fourth one. Not on the com, yeah? The com is for something else.
Okay, let's say this is my voltmeter. Okay, I'm drawing it over here.
Okay.
How should I connect this to the circuit for me to get a voltage?
This to this. If you want
No,
to
to
get a
the
volt,
circuit. How do you want me to connect the voltmeter to the circuit to get a reading on this?
I will connect it on it.
How?
On top of it, exactly.
On top of what?
On top of R1.
So you want me to do it like this?
Basically. No, it does not
Okay,
become,
very
this
good.
becomes series, parallel or series.
What is this? Parallel or series?
Parallel is from left to right, series from up and down.
No, parallel is when it is opposite to each other. You see R1?
Up and down means opposite. Does not mean that.
Okay,
Okay.
fine. You can think of it like that. No problem.
Okay. My bad. Okay.
All right. So, so this is how you connect in parallel. Okay. All right. Understand? So, what will be the sign on this? Positive or negative over here? Positive
Yeah.
or negative?
By the way, you got the what's it called? The RC, yeah.
Yeah.
And with the RC, did they ask you how did you get the 63%, or you just wrote it down?
Uh, they didn't ask me all that.
But you wrote the 63, yeah.
Yeah,
63%.
yeah.
That's 60. Okay. Okay. Continue.
Yeah. So you see how there's a positive and a negative,
Hmm.
and you know this is negative and this is positive, right? For the battery.
Hmm.
So what will be over here? Positive or negative for this side, and what will be over here this side?
Same thing, ولا? Positive and negative, positive and negative.
Over here is positive or negative. What?
This side?
Yeah, the left side.
Oh, I mean, okay, so if this one is positive and negative, well, the other one will be like opposite.
What do you mean?
Well, what do you want me to know exactly here?
What will be the value positive or negative over here?
Over here,
Yeah.
if the one under it is negative, then this one is opposite, so it will be positive.
No, wrong. It's negative.
Also negative? Oh,
Yes.
you said the one under it is negative.
Yeah, that's right.
Oh,
In parallel connection, it's always like that.
okay, so they're similar.
Yeah. And over
Okay.
here, it will be positive.
Mm-hmm.
Okay. Okay. Now I'm gonna erase this. Now tell me if I'm drawing the same circuit. Okay.
Mm.
With the resistor, all of that, battery, battery closing, R1. But this time, I want to find my current. How do I find it?
Define current.
Yes.
You want it? Yeah, ampere. Ampere is for currents. Okay.
Yeah.
So the multimeter, you will plug it in what? In the amp meter,
Okay.
and then you will connect it to the R1, which is no, I mean to the one that's like close to I1. So R1.
So I should connect it like this.
No, this will be the same.
So you want me to do it like this?
It will be voltage, or will it not?
You tell me. I'm asking you. I'm questioning you.
I don't know. That's the problem. I want you to guess. Shoot.
What did I show you right now? For ammeter, what is it? For voltage, what is it?
For ammeter, it's I. Yeah.
Yeah.
Why did you
I'll
change
draw
it
again.
already?
By mistake, I deleted it. It's okay. Okay. Tell me. How should I connect my ammeter? Should I connect it parallelly or series?
Amp meter.
Yeah.
You could what's it called? Use series this time. Not series.
Very good.
Yeah. The series. Okay. I
What were
was
you
good.
about
No,
to say?
I was saying I was gonna say parallel, but the series.
No, no, no. Voltmeter is always parallel.
Yeah.
Ammeter is always series. Memorize that. Keep that in your mind. Stick it in your head. Voltmeter is always what?
Voltmeter is always parallel.
Connected in parallel. And what is ammeter always connected in?
Series.
Don't forget this, okay? Keep that in your mind. Write it somewhere or whatever.
I think it's like here, like when my friend wrote, in parallel the voltage stays the same while current splits, and in series the current stays the same while the voltage splits.
Correct,
It
correct.
did not say
That's right.
it did not say that though. The what the
Yeah, but we're not
okay,
talking
so
about that. We're talking about how
voltage
to
is
connect the
series.
voltmeter and the
Yeah.
ammeter.
Voltage, well, you said voltage is parallel and ampere is series, yeah? Okay.
Yes.
And current is series.
Yeah.
Okay. So in
The
current we're
reason we
gonna
are
get series.
connecting it in parallel for voltage is because the voltage doesn't change if it is parallel. But if you take the current, then the current will be different in parallel. That's why we do not connect ammeter
Basically,
in
that's why,
parallel.
yeah, that's why what my friend said. Like you see this in his
Yeah.
question, like
Yeah.
RC circuit. I mean, not
I
RC.
have,
When he made the power transfer, I'm
yeah.
saying he wrote in his thing, in parallel the voltage stays the same. That's why
Okay.
it's like parallel. But in
Yeah.
series,
Okay.
the current stays the same while the voltage splits.
Correct. Very good.
That's the
Very good.
reason why it's series, and that's the reason it's
So now
parallel.
you understand, right?
Mm.
So ammeter will always be connected in series. So I'll be connecting it like this. Correct?
Mm-hmm.
Okay. Now you can watch the video.
Okay. Wait, bro. Give me a second. I will. What's it called? Let's come back at like 6. I want to go to the bathroom and get ready for prayer,
Yeah. Yeah. Okay. No problem.
and then how? Okay. So
Alright. Alright.
can
No
you
problem.
come? Or,
Huh? Yeah. I'll come. I'll come. I told you.
yeah.
Sorry.
Okay. At 6, please. Huh? Or you have something at 6?
Yeah. 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 Okay. Just
Okay.
call me at 6.
Yeah. Sure. Sure. I'm gonna go to the
Alright.
bathroom and pray and come.
Alright. Alright. Take
Okay.
it in. It's fine. Okay. Bye. Yeah, bro. Yeah.
Okay, I was gonna call you. Okay.
Yeah. All right, let's start.
This guy.
And then I will take the COM terminal, the negative one. Okay. And I'm just trying to measure the voltages at different positions.
Okay. So we'll take
Mm-hmm.
this one, the left, the second multimeter.
Hmm.
He'll use what? He'll use these two.
Measure the voltage
Yeah.
So
across
let's
the
just switch this on.
resistors.
V1, set it to whatever is asked in the procedure. Let's say 8
Yeah. Okay.
volts or 1. Set it. So let's just switch this on. V1, set it to whatever is asked in the procedure. Let's
Okay. So this is V1, and
Hmm.
this one is V1, and this one is like V2.
Yeah.
Okay.
say 8
No,
volts
no,
or
no, no,
7.
no.
Hmm.
For now, he's only setting it to V1. Just listen, look at what he's doing.
Yeah, yeah. He said this one is V1.
5.
Yeah, only that one.
Yeah. So he's setting this one.
Whatever
Follow
is
the
asked. So let's
instructions
just
very
switch this
carefully.
on.
Don't do anything on your
V1,
own.
set it to whatever is asked in the procedure. Let's say 8 volts or 7.5. Whatever. And V2.
Yeah, that's
Take the COM
VS2.
terminal, the negative one.
He just put them. He did not insert it to me.
Okay.
No, he's
And I'm
doing
just trying
something
to measure
else
the
now.
voltages at
He's
different
connecting
positions.
the
Set it to
voltmeter to
whatever.
the
So let's
thing
just
in
switch this
parallel.
on.
Remember, I told
V1.
you
Wait,
voltmeter
wait,
should
wait.
be
Set it.
connected in parallel.
What did he say?
Remember, I told you voltmeter should be connected to the resistor in parallel.
Voltmeter. Yeah, well, because the resistor is always parallel.
No,
Hmm?
voltmeter is always parallel. Resistor is always in series.
I'm saying because voltmeter, yeah. Voltage is always parallel, and series is what's it called? Series is for the current, yeah.
Yes.
Okay.
Set it to whatever is asked in the procedure. Let's say 8 volts or 7.5.
Okay, let's just say, yeah. Then
Mm-hmm.
plug in two wires, yeah. Okay.
Whatever. And V2.
These are all just connections. You need to memorize
6.5 or
these.
7 or whatever.
Or just understand
So
them
just
if you
follow
can't
the procedure.
memorize.
Okay. Can I? Wait, it's 2 minutes and 57, yeah. Yeah. If I
Hmm.
just look at it, I can like I think show you. Okay, so first one, we bring a wire, yeah, small wire. This one, we call this
Yeah.
R1. We put it in the junction here,
Yes.
and then second wire, we bring it here. We bring it to the junction here.
Yes.
Okay. Oh damn! No, I feel like I forgot. Okay. We have this guy here and this guy here, yeah.
Hmm.
And then we'll take two wires. We'll take a long wire here. We'll put it to the positive
Correct.
here, and we'll take another wire. We'll bring this to the negative here,
Yes.
and
Good.
then we'll bring a wire here to the positive and here to the negative.
Yes. Good.
And then we'll take this voltmeter. We'll put two wires on this one, on the left one and the
Hmm.
right one. Yeah, that's it until now.
Equations.
Yes.
Whatever
Correct.
is mentioned. Yeah, so just follow the procedure. So, get all the voltages. VS1, how do I get VS1 now?
Okay, so wait, I'll just write now in power supply. Just
Hmm.
what? Just get the what's it called? Just get the just put the procedure here. Put the procedure.
Hmm.
Procedure voltage on the V. So could be what? Could be 8, could be 9, yeah? Huh?
Yeah.
Okay. So could be 8.0
Yeah.
or 9.0, etc. Okay.
VS1.
VS1. VS1 would
You see here, right? This is my VS1. Positive, negative.
Okay. Okay, so first we'll go to the voltmeter. We'll put the left one on what? On the on under it, and the fourth port, which is like the voltage on what? On the one here above it, yeah. On the positive and
Hmm.
This is my VS1. Got it for the
On parallel. Remember parallel.
voltmeter.
yeah,
V1.
because they are parallel. But what did he take them?
would be in parallel with the resistance.
Watch again.
In parallel to R1. So
Yeah.
positive, negative.
Wait, what is he doing now? Why did he first?
Would be in parallel with the resistance.
What happened?
In parallel to R1. So
Yeah.
positive,
With the resistance.
So he
V1.
made a mistake here.
No,
from the
no, no.
voltmeter.
Look what he's doing.
Okay, first he did this.
He's connecting
V1.
the voltmeter in parallel to the resistor 1
Would
so
be
that he
parallel
can
to
get the
resistance.
voltage in the
Parallel
resistor
to
1, which is V1.
Would be in parallel with the resistance.
It will be parallel with the resistor.
In parallel
Wait,
Yes.
I'm just saying here. You see what he did here first?
here, right? This
Oh,
is
you
my
put it
VS1.
in parallel.
Okay,
Yeah.
he put the
Positive,
one here and here.
negative.
Yeah. Okay, so why did he take the negative one? He put it above it here.
Because it's connected in parallel.
This is my VS1.
So he made a mistake here. Yeah. He should have done that. Yeah.
No, it's not a mistake. He's doing the next one now.
Oh, because he already finished the first step.
Yes, correct.
So he got his number, which is like 8.
Hmm.
Got it from
Yeah.
the voltmeter.
What did he say? He said something.
Negative. This is my VS1. Got it from the voltmeter.
Okay, so that's how he got V1. Okay. Then
Hmm.
VS1 is equal to like this number, for example, 8.0. Then now he pulled out the thing. What's he gonna do?
V1.
V1.
Would be in parallel with the resistance.
In parallel to
Okay, so you know how he got VS1? He put the red one here and the black one here. And how to get
Yes.
V1 now
to
is like
R1.
this.
So
Yeah.
positive, negative.
He put the positive here and the negative on the what? On the R1.
Yeah.
Yeah, and then he got
Okay,
what?
whatever the value is.
4.51. This is the V1, yeah? V1 is equal to 4.5.
Don't write that down, bro. It's not
No,
important.
just because I want to know if it's similar. I'm not writing
Hmm.
the number, I'm just like, this is what, 4.5 or 45?
I don't know. I can't see clearly, but don't write it. It's not important.
Okay, that's how we got
V2.
V2 would be in parallel with V2.
V2 would be parallel with what?
R2. Again,
R2.
so where's the positive and negative? You have to know. So based on the circuit diagram, we
Yeah.
were having the current in this direction. So this was positive,
No.
this was negative. Get your V2. V3.
Varan inga
Again,
irukama.
the current direction based on the circuit diagram coming from up over there. So this, again, the current direction based. Get your V2. V3. Again, the current direction based on the circuit diagram coming from up over there. So this is my positive, this is my negative. And VS2, positive, negative. Same thing, just get the voltages based on the current directions you had set, the positive and the negative terminals you had set in the circuit diagram. Record those values. Plug them into the equations which you have. And verify the Kirchhoff voltage rule, which basically says the algebraic sum of voltage changes in any closed loop is equal to 0. You have 3 loops, verify that for the 3 loops. Next was the current rule, the Kirchhoff current rule, right? For that, I'm going to use my ammeter.
Okay, he didn't use the multimeter, just
So
switched.
now this is my ammeter, the positive.
Hmm?
I'm just saying he just
The
switched.
current would be again low value, so I can use the milliamp terminal, and this is the COM. This is the junction point. I need my terminal, and this is the.
Okay, wait, bro. This one is what? What is this called? I'm saying, you know what I call them? I call this current 1, current 2. This is COM, and this is voltage, the rightest one. The fourth one.
Yeah. Okay.
What is this one
Wait,
called?
let me zoom in.
You can't see it. I mean, you can't
That-
read it.
That is. It will be written on top. Don't worry.
The COM. This is the junction point.
You don't have to
I need
memorize
my
that.
I1, I2, and I3. So the current entering the junction should be equal to the current leaving the junction. What is the current entering the junction? I1.
If you get Kirchhoff's law, how many times are you going to call it, Professor? Like after you finish one, what's it called? Like
Just
one-
pray to God you don't get this.
Bro, anytime it's like something I don't study, it counts. This is my luck.
Yeah. Then you're cooked.
And I3 is leaving. How do I get I1?
Well, there's no way I get less than 10, bro. It's swear to God. But I lost hope.
You won't get
of
less
getting a
than
good
10.
mark. I want to just pass, bro. Fuck my life.
What should I do?
I
With
want
me,
to
or
do
you
amp
think you-
meter. The amp meter should be connected in series, and you want I1. So you're gonna have to connect the power supply to the amp meter, And
You think
Yeah,
so you're gonna have to connect the power supply to the amp meter. And wait, no.
just R1
Yeah.
is here. So I'm going to connect my ammeter here, right? So for that, I'm going to break the circuit because you want the ammeter in series. So from R1 here, force your current to go through the
Look,
ammeter, and from here it
focus
goes
on this
back to
one.
the junction point.
This is for
And this here
ammeter.
is
Okay, so he put it
This
on
is
the
in
junction.
series.
giving me the current I1.
This is
For
different
the
from the
first
voltmeter. Look, he's making different connections now. He's removing something and he's adding it.
He just removed
It's
the
because in
R2.
ammeter you have to connect it in series.
20 milliamp, shift and get your value down to the 2 decimal place. This is in milliamp, I1. Similarly, I2.
9.5.
So for I2, first step, get this wire back as it was, get your I2. This is the direction of the current now, so I'm going to break this wire here, get my ammeter in series. So positive goes in there, back to the junction point. This is my I2. You notice you have 9 and 13. What do you expect I3 to be? The sum of those two, right? So I3 will be, now you break this part here. But be careful, the positive will be here because you're trying to have your ammeter at this point. And the negative is going to be here. So this is the place where those two, right? To the here, get this is the direction of the current now. So I'm going to break this wire here, get my ammeter in series. So
And this one was what? This one was originally connected to this guy. Yeah.
positive goes in there, back to the junction point. This is my
Yeah, but there's no wire here. He just. Okay.
I2.
Yeah.
You notice you have 9 and 13. What do you expect I3 to be? The sum of those two, right? So I3 will be, now you break this part here. But be careful, the positive will be here because you're trying to have your ammeter at this point. And the negative is going to be here. So this is the place where you're going to have the ammeter. And now it's more than 20, so you will switch the range and get your current.
How did you know it was more than
And
20?
now it's
Because the thing was showing this.
more than 20, so you
Yeah,
will
do look
switch
at
the
that.
range and get your current I3. You
Oh, he got his I3.
verify the junction loop. This was for the first part where you had two power supplies, right? So you got the voltages and the current. Similarly, you will do it when you have one power supply and 4 resistors. So for that, I'm basically going to remove the VS2 here. And instead of my VS2, I'm going to have another resistor connected. And I'm just going to repeat the same procedure. So if this was my ammeter wire, the rest all is the same. So everything else is the same. I just have a resistor connected, R4. I'm going to measure R1, V1, V2, V3, V4. I'm going to measure the currents I1, I2, and I3 and verify the Kirchhoff voltage and current rules. Okay, as it was. So just use your voltmeters and ammeters based on what we did. Voltmeter always connected in parallel, ammeter always connected in series. Clear?
You heard what he said?
Voltmeter always connected in parallel, ammeter always connected
Yeah.
in series.
Ammeter series. Parallel.
That's what I've been keep telling you, bro.
It's voltage. Oh, the wiring is so confusing though. Okay, how do I get my VS1? Is when you put what? When you put your thing here, this guy.
This was negative. It's on V1.
That is VS2.
The negative. This is the voltmeter. So I will take the V terminal.
Go back.
This is the
V1.
Yeah.
positive one. And then I will take the COM terminal. The
This
negative
is for
one.
VS1.
And I'm just trying to measure the voltages at different
Huh?
positions.
No, V1. My bad.
Look at what he said.
And I'm just trying to measure the voltages at different positions. So let's just switch this on. V1. Set it to
Okay,
whatever is
V1.
asked in the procedure. Let's say 8 volts or 7.5. Whatever. And V2. 6.5 or 7 or whatever it is.
Whatever
So just
it is.
follow the procedure. So, get all the voltages. VS1, how do I get VS1 now?
VS1. He will plug the red one here and the black one here to get the VS1.
VS1.
Yeah.
Then you will get like 8, for example.
VS1
Just here, right? This is my VS1. Positive, negative. This is my VS1. Got it from the voltmeter. V1.
Okay. This is VS1. Now V1 is what?
would be in parallel with the resistor.
In parallel to R1. So
Yeah.
positive, negative. Okay, whatever the value is.
Positive and negative. This is what he got. He got like 45.1.
Yeah.
I mean 44.51 here.
V2,
This is V1. And now we want to get V2.
V2.
R2. Again,
V2, okay, V2 is now at the other side. Now R2.
so where's the positive and negative? You have to know. So
Yeah.
This is my positive. No, this is my positive and this is the negative. Yeah.
Based on the circuit diagram, we were having the current in this direction, so this was positive, this was negative.
Yeah, and
Get
this is my V2 now.
your V2. V3.
Okay, so my V1 is like 3.1. And now at V3 is equal to what? V3 it will be like in the middle, yeah? I3.
Yeah.
Again, the current direction based on the circuit diagram coming from up over there, so this is my positive, this is my negative. And VS2, positive, negative. Same thing, just get the voltages based on the current directions you had set, the positive and the negative terminals you had set in the circuit diagram, record those values. Plug them into the equations which you have, and verify the Kirchhoff voltage rule, which basically says the algebraic sum of voltage changes in any closed loop is equal to 0. You have 3 loops, verify that voltage sum of voltage change, and verify the Kirchhoff voltage, the positive and the negative terminals you had set in the circuit diagram, record those values. Plug them into the same thing, just get the and VS2 negative. Get your V2. V3, again the current direction based on the circuit diagram coming from up over there, so this is my positive, this is my negative.
Okay, so he puts his positive here and his negative here. This is V. How to get V1 is just basically bring the positive and negative here and here, yeah? VS1 I mean.
Yeah.
And then V2 just bring
Yeah.
the blue.
Just look
black
at the
and
video
negative.
carefully and make some drawings so that you don't get confused.
Yeah, yeah, and this guy you bring it here.
And write it down, write all of them down so you don't forget.
How many drawings am I gonna draw for each wire? Okay, so
Or just keep it in your mind, like try to memorize, that's what I do.
if I just like write numbers, maybe it will be better. 1, 2,
Yeah, just do that.
4,
I
5,
can remember in my mind, even you can try to do that.
8.
That's helpful.
Yeah, no, okay.
Because in the exam you don't have to give looking at the notes.
Okay, so at VS1, which is like 8.0, okay, so you know what I was just saying? At like this one.
Just watch the full thing again, one more time, just for some
Now I'm just
clarity.
trying to measure the voltages at different positions. So let's just switch this on. V1, set it to whatever is asked in the procedure. Let's say 8 volts or 7.5. And V2, 6.5 or 7 or whatever.
Multimeter 1, multimeter 2, multimeter 3, and multimeter 4, or V2, com, amp meter and amp and amp. Okay.
Whatever it is mentioned. Yeah, so just follow the procedure. So get all the voltages. VS1, how do I get VS1 now?
VS1 you put the negative and positive above this one and this
VS1.
VS1. VS1.
Just here, right? This is my VS1. Positive, negative.
Positive and negative. Okay. So at so multimeter 1 and 3. Okay. So plug V2 to 1 and
Yeah.
okay.
This is my
And plug the com to what? To 2. Yeah, okay. No, not to 2, to 7. Yeah. I will call this number 7.
my VS1. Got it from the
It's like this, see? 1, 2, 3, 4, 5, 6, 7, 8, 9.
voltmeter. V1
Would be in parallel with the resistance.
in parallel to R1, so
Yeah.
positive.
Okay. So plug V2 to 1 and plug what's it called? Yeah. MT4, MT3, multimeter 3, and plug the what's it called? Com to 2. Okay.
Negative. Okay, whatever the value is. V2,
V2 would be in parallel with V2.
R2. Again,
R2.
so where's the positive and negative? You have to know. So based on the circuit diagram, we were having the current in this direction. So this was positive, this was negative.
They will have to give me the same direction, yeah? They can't just like
They'll
create a
give you
new
the
box.
directions and the courage and all of that. Don't
Huh?
worry.
They won't just buy a new box for me exactly, name it
No,
Ramadan
no, no, no,
Sari
they won't do it.
and make it in a triangle shape and just like make
No,
it
no,
cry.
no, no.
Okay.
Get your V2. V3,
Okay, wait.
this was negative. Get your V2. V3, Again, the current direction based on the circuit, your V2. V3 positive, this was negative.
Okay. Plug V2 to number 4 and plug the COM to number 3.
Get your V2. V3, again, the current direction based on the circuit diagram coming from up over there. So this is my positive, this is my negative.
Okay. So
And VS2,
3.51.
this is my
VS2, yeah, okay. VS2. Now I want this to come because I understand it, bro. This is VS. Okay.
What?
Okay, so what's it called? I'm saying I want this to come now because I understand V2 to number 6, yeah? Yeah, this is 6 to 6. And plug, what's it called? Plug COM to 3. Okay, plug COM to 3. Not to 7 to 8. Yeah, because this is number 8, yeah. To 8.
negative. And VS2, positive, negative. Same thing, just get.
VS2 is what?
And VS2, positive, negative. Same thing,
Okay, so VS2 is the same but other side. Is VS1,
Yeah.
Plug V2 to number 5 and what's it called? V3 and plug COM to number 9. Yeah, to 9. Okay.
Just get the voltages based on the current directions you had set, the positive and the negative terminals you had set in the circuit diagram. Record those values. Plug them into the equations which you have. And verify the Kirchhoff voltage rule, which basically says the algebraic sum of voltage changes in any closed loop is equal to 0. You have 3 loops, verify that for the 3 loops. Next was the current rule, the Kirchhoff current rule, right? For that, I'm going to use my ammeter.
Now, amp meter. So, this guy again is what? MT1 amp and MT2 amp and COM and V2. Okay.
So now this is my ammeter, the positive. The current would be again low value, so I can use the milliamp terminal, and this is the COM. This is the junction point. I need my I1, I2, and I3. So the current entering the junction should be equal to the current leaving the junction. What is the current entering the junction? I1 and I2.
Current entering the junction. We know I1 from R1 and R2, they're both entering, but I3 is not.
And I3 is leaving. How do I get I1? What should I do?
Okay. How do you get I1? I1 is equal to what?
With me, or you think you?
The amp meter should be connected in series, and you want I1. So you're gonna have to connect the power supply to the amp meter. And, wait, no.
R1
Yeah.
is here. So I'm going to connect my ammeter here, right? So for that, I'm going to break the circuit because you want the ammeter in series. So from R1 here, force your current to go.
Take V2 to MT2 and break off, what is it called? Break off 2 and break off 2 and plug, what's it called? Plug at 2, yeah. Okay.
Go through the ammeter, and from here it goes back to the junction point.
At 2. Then plug COM
You understand what's going on?
to 3 or the junction, yeah. 3
You understand?
junction.
Rashid?
Yeah, I'm writing it. What?
Yeah, okay.
Now this here is giving me the current I1. If it is less than 20 milliamp, shift and get your value down
Just do your writing if I need to ask you.
Yeah.
to the 2 decimal place. This is in milliamp, I1. Similarly, I2. So for I2, first step, get this wire back as it was. Get your I2.
I2
This is the direction of the current now. So I'm going to break.
Yeah. Break of 4.
This wire here. Get my ammeter in series. So positive goes in there.
So plug MT2, the M series, to number 4.
Back to the junction point. This is my I2. You notice you have 9 and 13. What do you expect I3 to be? The sum of those two, right? So I3 will be, now you break this part here.
I3 is what? Break of number 6. Yeah. Break of 6.
But be careful, the positive will be here. Because
Break of 6. Then MT2 plug 3.
you're trying to have your ammeter at this point. And the negative is going to be here. So this is the
And come to what's it called? To number 6.
place where you're going to have the ammeter. And now it's more than 20, so you will switch the range and get your current I3. You verify the junction loop. This was for the first part where you
But what's the verified junction rule? Loop 1, 2, loop 2, loop 3. What the fuck?
you had two power supplies, right? So you got the voltages and the current. Similarly, you will do it when you have one power supply and 4 resistors. So for that, I'm basically going to remove the VS2 here. And instead of my VS2, I'm going to have another resistor connected. And I'm just going to repeat the same procedure. So if this was my ammeter wire, the rest all is the same. So everything else is the same. I just have a resistor connected, R4. I'm going to measure R1, V1, V2, V3, V4. I'm going to measure the currents I1, I2, and I3 and verify the Kirchhoff voltage and current rules. Okay, as it was. So just use your voltmeters and ammeters based on what we did. Voltmeter always connected in parallel, ammeter always connected in series. Clear? Again, look at your lab reports, follow the equations, how they were derived, and just practice the connections for today at least.
Okay. God damn.
Which one is the voltmeter? Highly recommend all of you to do since you were all online, right? It's just a little tell you.
So you think you
Any
understand now?
section are online? That's well now.
No. He's saying you can understand it through online.
No, it's a part of the other section that are online. For some people that are online, it's weird. Force and a current carrying. This is lab 9. Okay. Experiment 9 is equal to this.
Recommend all of you to do since you were all online, right? Is this section all online? And was it only this experiment or was there anyone any
I
other?
believe just this.
Just this, okay. Here, what we had, so just take some wires and we'll take the multimeter. Straight action is so this is the magnetic assembly. You know, you
Okay.
have the north and the
magnetic assembly.
South pole here, we just place it on this balance. So initially, let's just it's already plugged in. Let's just switch this. Yeah. You have the north and the south pole here. We just place it on this balance. So initially, let's just so this is on this balance. So initially, let's just it's already plugged in. Let's switch this. You have the north and the south pole here. We just place it on this balance. So initially, let's just it's already plugged in. Let's just switch. Yeah. So initially, we switch it on. Press. Make sure nothing there is zero, and we place our magnetic assembly. Let's just place it like this, for example. Right. These are the different lengths. What the lengths are, it's mentioned. So you have a reference number SF39, SF41, SF38. You will have a table if you look at your lab report. There were these reference tables. So SF39 means this particular length in centimeters, SF38 means this particular length. So you will know what exactly the length is of this wire. You take it out. And you put it into this accessory. So this is the length of the wire which you are changing. And for this experiment, we were trying to verify the relationship between the magnetic force and how it is affected by changing the current in the wire or by changing the length of the wire or the magnetic field. The magnetic field we are not changing, so it's this assembly we're keeping. What we will do is we will change the current and the length. For the first part, there were two parts. So the first part, I was keeping the length of the wire constant and the magnetic field B constant. So let's say I fixed this. This is the length. I'm going to fix it. I'm going to place this inside here. I can change its height. So this is I can just increase, and you have to make sure that you place it properly inside. Again, making sure that you are not touching the base. So this is something you should practice, and you're not keeping it like that. Don't be clumsy and keep it outside here. So you have to make sure it's inside the field here and it is lowered. So try to lower it as much as possible, but again making sure it's not touching the base or the base is not touching the magnetic.
Can it be touching from the other sides?
No, it shouldn't be touching from any side.
Okay.
It's completely free, and but it is placed inside. So you have a north and a south pole. The wire is inside that field, not like this. You know, you have part of it out. Outside now. So this is something you should take care of when you're doing the experiment. It's inside here. And for the connections, all we had is an ammeter in series, and you know, it goes in there. So from the positive, I'll have an ammeter in series, so it goes to 20.
Okay.
And from the com, it goes to one side of the assembly here, and from the other side it goes back to the negative of the power supply. That's it. So I just have an ammeter connected in series to record what the current is. Now if I switch on, this is going to be a current source, so I maximize the voltage, and if I increase the current, if the mass is increasing, we are fine. If it is decreasing, then just switch the direction of the current, right? You know, so this there and this here. It depends, because it depends.
Oh shit! What the fuck?
Negative of the power supply. That's it. It goes to one side of the assembly here, and from the other side it goes series, so it goes to 20. And from the com, it goes to one side of the assembly here, and from the other side it goes back to the negative of the power supply. That's it. So I just have an ammeter connected in series to record what the current is. Now if I switch on, this is going to be a current source, so I maximize the voltage, and if I increase the current, if the mass is increasing, we are fine. If it is decreasing, then just switch the direction of the current, right? You know, so this there and this here. It depends, because it depends on your north and the south pole, how you have connected it, and it depends on the current direction. We want to set it in a way that the mass is increasing, right? So flip either the direction of the current or the direction of the magnetic field. Let's see. So I have it here, 1 amp or 1.5. What's happening to the mass? 161. It's increasing, so we are all good. We can start the experiment. So let's keep it to 1 amp here. Note down this mass. But before that, what was the initial mass? M naught. How do I get M naught?
Just a minute.
When there is no current flowing in there, right? So when there is no current flowing, this is my M naught, which is 161.
I'm not. Just mass of the node is what? Turn off power supply. Show
1.49 grams. This is my M naught. 1.49 grams. This is my M naught. When 1 amp is flowing, it increased. Can you find delta M? Yes. So delta M is just M1 bis M mass minus M naught. You get delta M. M is just M1 bis M mass minus M naught. You get delta M. Can you find the force because of this change in mass?
Yes. Delta M
Times G. That's it. This is the force which is being exerted from to this wire because of that current. You increase the current.
Wait, Professor, this is an ammeter, right?
Yeah, this is an ammeter. Actually, it should be switched on to the ammeter. So the current, you are noticing it from there. So 1, 1.2, 1.4, 1.6, and it'll tell you for different values of the current, you are getting the change in mass. You plot a graph. If you recall, we plotted the graph of force, which we were getting. If you recall, for different values of the currents, you are getting the change in mass. You plot a graph. If you recall, we plotted the graph of force, which we were getting, versus the current, and from there I get the slope. The slope, what's the slope equal to? LB, right? Because our equation was IL.
Oh, God.
What's the slope equal to? LB, right? Because our equation was ILB, so the slope is basically equal to LB. B. The right, because our equation was IL. What's the slope equal to? LB, right? Because our equation was ILB, so the slope is basically equal to LB. The length of this wire is given to you. You know what the length of this wire is? It's mentioned, so you have SF39. You look at the reference table. The length is given. You have the slope. Can you find the field B, the magnetic field? Just divide it with that, and you get your magnetic field B.
Okay, so in the exam, it will be given, right?
What will be given?
The table, or
The table, no, the table will be given. The lengths will be mentioned, the currents will be mentioned. So it'll tell you, okay, set the current to this and do the experiment. So it'll tell you. This was the first part where we
BL F is equal to IBL, or IBL. Slope is what? Is F over F. Power force over IB. But if I get this, the shit is gonna be bad. There's so many things. Yeah, bro, by the way, Praveen, you here? Hello? Praveen, you here? Your mic is muted.
are changing the current here, right? And I'm fixing the length. So this, what you have to practice is how to do the connections. The second part, I'm fixing the current. So
Hello? Bro? 10 power of -3 and
So I'll just fix the current here.
B from the slope F is equal to B IBL.
and I have to change the length. So let's say I will fix the current, so it'll tell you fix the current to 2 amp or 3 amp or whatever. Let's say I'll fix the current. Now each time you have to measure the mass for different lengths. First step, again, M naught. How do I get M naught?
Without current.
Without current, switch off, get your M naught. Next, get your mass for different length. Let's say this is my first length, fixed current, switch it on, don't change the knobs, it was fixed, and then just get your change in mass. Next, I change the length, switch off, increase this, get the length out, and use the other length provided, SF37. Put it in here.
They'll tell you which length to change it to.
Yes. And back inside here. Again, making sure that you're not touching from the base or from the side, and it's placed inside. This is your new length. Is the mass same?
No.
If the length is changing, the mass will also change, right? Get that mass. Again, switch off, remove, get the next length. And repeat. You will have all this information, tabulate that, plot a graph. This time you're plotting a graph of force versus length. You will notice as the length is increasing, your force is increasing. Get the slope. From the slope, you get your magnetic field B. Do you know the current which you had set? Yes, whatever was set. So just slope divided by the current will give you the magnetic field. That's now, I mean, in the lab, what was done is, this part was done for you, the data was given, so please practice how the connections are done, and then we can follow the report later on. Clear?
So from the
I don't think اقدر اسوي رسمه.
سوي
مالته
بليز سوي اليوم زي
عندي حفظ.
شو حفظ؟ خلصت تدرسه؟
باكر عندي الوطن يعني I will talk on stage.
شو هذي؟
لازم احفظ.
انت خلاص سوي باكر.
power supply, positive, and to the 20A, because we
Okay.
want from the power supply, positive. and to the 20A because we
Okay.
want to start and make sure we don't burn.
Yeah, actually in this experiment your currents will be higher than 200 milliamps, so you have to use the 28.
Okay. Then you plug it into either one of the whites because if you plug it in here, it could be a positive or a negative. It's just
This is the
absolute
direction
value.
of flip, exactly. And then from the other side.
Other side, back into the longer one. The other side, back into, not the black, you just use the white, back into the
Good.
power supply.
That's it. And then you have a Tesla meter. So there's a window.
Bro, you here? Hello?
Experiment your currents will be higher than 200. Milliamps, so you have
And to the 20A because we
Okay.
want to start. and make sure we don't burn.
Yeah, actually in this experiment your currents will be higher than 200 milliamps, so you have to use the 28.
Okay. Then you plug it into either one of the whites, because if you plug it in here, it could be a positive or a negative. It's just
Just the
absolute
directional
value.
slip, exactly. And then from the other side.
Other side, back into the another longer one. The other side, back into, not the black, you just use the white, back into the
Good.
power supply.
That's it. And then you have the Tesla meter. So
Yeah, so for the Tesla meter, you turn it on. And then you wait for it to set up, and then you go to 0, and then you hold reset until it makes a beep, and then you should be ready to go.
that's it. So you basically had to get the probe here, the tip of the probe at the center of the circular loop. So initially we wanted to keep it straight. And let's say we had set it to the 10 centimeter mark here, and then we try to find the center. How do you find the center?
Straight. Hello, bro.
Hello,
Where did you go? He disappeared.
hello.
Hello?
Can you hear me?
What's up? How are you?
Hello. Can you hear
Hello,
me?
can you hear
Hello.
me? Hello?
Yeah, can you hear me?
Okay. I can hear you. Where
Yeah,
did you
okay.
go? What happened?
Great.
Huh? Where did you go?
I went to the washroom.
Bro, an hour? You disappeared.
No, I just came back. Where are you?
I'm on the last lap.
Ah, okay. Hey, do you have any doubts?
Huh?
You have any doubts?
Yeah, some. But what I want to ask is this: what's it called?
What?
Astaghfirullah, yeah. For you, how many questions did you get? Like for both? It was 2 pages or 1 page of questions?
One page. But then, like, it was compressed into, like,
Hmm?
one page. It was one page compressed into all the questions.
Yeah, like how many questions were there?
Like, 6 into to 12.
6 into 12? You mean 12 or
No,
6?
6 into 2.
What? You mean
12
like
questions
6
were there.
times 2, yeah, like 6 questions, 6 questions.
Yeah.
And each question, does it like tell you what it wants? Like this question, I want you to give me the currents and like the
Yeah.
that. And second question is discuss your results in that one.
Yeah,
And the
correct.
third question is like do the slope and like find the graph, like something like
Hmm.
that. Did you draw
Yeah,
the graph
correct.
also for you?
Yeah, we have to draw the graph.
Did you give you graph on the paper?
Yeah, they'll give you the graph paper, don't worry.
I'm not worrying about that. I'm thinking about what I'm gonna make up. Did you make up some
No,
data when you like like something was like not good or not close or like bad?
what?
Did you make some data?
No. I just use the
The ones that you got?
percentage error.
Hmm?
What are you saying?
No, I'm saying your data. Did you not fake any? Like all of them? Did you try to make
No,
up?
I didn't do that.
It's good.
But you can if you want.
I don't think I will. It has to be related. Like you can't just make up data. Like if you like, let's say the second they give you like 5 minutes, yeah, for like
Yeah.
events or something like that. One experiment for events.
Yeah.
What's the RC circuit? Yeah, it's the event one.
Hmm.
Huh?
It's okay. You don't have to memorize. They like most probably like I told you, yeah, you have like 3 turns. You can use that to like ask the professor if what you're doing is correct or wrong. So don't worry.
Okay.
The sensor depends if you're moving back.
If I don't call him or ask him, does he come and check also? He has to come and check.
No. If you don't show him, then you cannot start it. Only after you show him, you'll be allowed to start.
Like your paper, you mean? They will give you a paper?
No. The machine, like on off.
What do you mean? Like I
Like
have
the
the
power.
yeah.
You cannot turn it on unless he gives you the approval.
Mm. Okay. Oh God, man. I don't wanna
Yeah.
fail.
Laugh, laugh, laugh. Come on.
No, I'm not gonna laugh. I'm saying you don't wanna fail. Okay.
Oh my god.
RC circuit.
Don't waste time. Don't waste time.
I'm
Play.
no, I'm
Watch it.
writing. I'm writing.
Okay. Okay.
Back and forth, you're trying to find the highest
Yeah.
value. If you're going up and sides, you want to find the lowest value.
So if I switch this on, let's say I had fixed my current to some particular value, 1 amp or whatever is mentioned 1.2. So if I 0, so to measure now, it should give me the value again. Let's
Trying to
set it straight. Probe here, the tip of the probe.
hold set up, and then you go to 0, turn it on.
So
Yeah, so for the Tesla meter, you turn it on, and then
Do you have to do anything for the Tesla meter connecting, or it's just like it's there?
No, you don't have.
Okay.
you wait for it to set up, and then you go to 0, and then you hold reset until it makes a beep, and then you should be ready to go.
that's it. So you basically had to get the probe here, the tip of the probe at the center of the circular loop. So initially we wanted to keep it straight. And let's say we had set it to the 10 centimeter mark here, and then we try to find the center. Center. How do you find the center?
The center depends. If you're moving back and forth, you're trying to find the highest
Yeah.
value. If you're going up and sides, you want to find the lowest value.
So if I switch this on, let's say I had fixed my current to some particular value, 1 amp or whatever is mentioned 1.2. So if I go to measure now, it should give me the value. Again, let's just verify. If I switch off, it's 0. So if I switch on, now it's giving me some magnetic field. Notice it's in millitesla. And what's the current which is flowing? You have 1.17. Yeah. So we need to get this tip at the center of the loop. So in order to know if it's at the center or not, if I move it this side in the Z direction, it will increase and then it starts to reduce. Have a look over there. So it's reducing now, right? It should be straight. If I go back, what's happening? It's increasing. How do I know if I'm at the inside the plane?
It's the
It should be the
maximum
maximum. So first step, come inside the plane where the field is maximum. Then I move these directions
Up and down to
up
the
and down
least.
and left and right. I'll be at the center when the field is
The least.
minimum, right? So in that case, it should be the minimum, because if I go closer to the wires, it'll increase. So I have to be at the center, it should be minimum. So in the plane, maximum, and then minimum from the other two axes. And that's it. Once you're at the center, this experiment, we were changing the current. So if I increase the current, what happens to the magnetic field? It would increase, right? So they're directly proportional here. So as I increase the current, the magnetic field is increasing. And in the second part, what we did is we fixed the current and we changed the Z. So if I fix the current and change the Z, let's say I move the Z 1, 2, 3, 4, 5, 6 each time, I am noticing the magnetic field is decreasing. It's maximum when it is at the center. And if I move in this direction also, it's decreasing. So just, do the connections, set.
Oh God. Okay. And bro, hello? You hear?
Yeah.
And for the data sets, they give you like a lot of stuff that you have to put, or like two or three. Hello?
Yeah.
You know how the RC circuit like once, let me show you.
Watch the video. It'll be easier to explain.
I watched already.
You watched it?
Yeah. I'm like checking it, like you see this one for you, for example, this one you did it, yeah?
Which
Did you
one?
like do like stuff that are similar to this?
Yeah.
Like you just you put all of your stuff, you get your numbers, and you put the VC and time, yeah?
Yeah, correct.
And then you plot the graph here first.
Yeah, correct.
Okay, and then the time constant. Wait, is there time
correct.
constant for this law?
Which one?
For force on this one,
Propose?
on
No.
praveen. I don't know why this guy asked here. Check. I mean,
No, no, no. It's not that.
okay, where is it? This guy, see?
Yeah.
See, he asked here. Can someone explain how to type in graph in experiment 7?
Yeah.
Isn't
No,
this?
no, no. It'll be given in the circuit. Don't worry.
No, I'm
Like if you
saying,
want to get the diagram,
isn't this
you'll
like, does he mean the RC circuit or he means the, this guy?
show me.
There is no time in this, is there?
Mm,
Why
wait,
constant?
show me.
There's no time constant on the force. I mean, force in a current coil.
Wait, zoom in.
Huh?
Let me see, zoom in. Yeah, there's no time constant.
Okay. So in this one, in your case, there was time, yeah? Time constant as well.
Yeah, there is.
Did
Yeah.
you have to write, did you have to write all the equations or you just wrote this
No,
one?
no, no. You just write the final
0.63.
equation.
You mean this one, yeah? 0.63. Just open it here. You see this?
Hmm?
You see this? You see this?
Yeah. What are you doing?
No, I'm just checking the. I mean, you see this, yeah? That's what
Yeah, I
you.
can see it.
Yeah, that's what you did.
Yeah, that's what I did.
And then what was your other lab? You said V-Stone Bridge.
What?
Your other lab. Wait, is my voice low?
Fuck.
Wait,
Wheatstone Bridge. Wheatstone Bridge.
just give me a second. Hello, can you hear me?
Wheatstone Bridge.
Yeah, you did this one. You mean?
Yeah.
Well, this guy.
Yeah, that.
Is it that long? Like you did this. You put all. How
No,
many
no, no.
data?
It's
How
not
many
that
data
long.
sets did you put? Like this one? Did you put like
Hmm?
5, 6?
5.
5. Oh, okay.
Yeah.
And you had to keep on increasing it by how much? By like 20?
It depends. They'll give you.
What did they tell you?
I got 65, 85, 120, 150.
Hmm.
Yeah.
Oh. Okay, I'll just write the last one. Then we'll do the last thing. Then
Mm.
well, my last thing is thus. I have to know how to do like the labs. Some of them.
Yeah.
Okay. This is which lab? This is lab 10.
Tomorrow, do we have a quiz for engine 112? 211?
No, I don't think
Rashid,
so. I don't think so.
you sure, yeah?
Yeah, we did not. Only 5 quizzes until now. We did. You won't say.
Hmm?
We only did 5 quizzes until now.
Yeah. Did he upload all the marks?
For quizzes, yeah.
All of them?
I mean, quiz 5 we did not.
He did not upload for quiz 3 for me.
Quiz 3. Quiz 5 and homework 5 is not graded until.
Quiz 5. Homework quiz 3 also he didn't grade for me. Should I go talk to him?
Oh, he will give you the grade. You can go talk to
Hmm.
him later. After the final, go talk. Beg for marks. That's my
Yeah.
idea. y1 minus y2. y2 minus y1 over x2 minus x1. Give me my data. And millitesla is just 10 power of negative 3. Yeah?
Hmm.
Bro, when I want to find the graph, this is like, let's say this is my y and this is my x, yeah?
Hmm.
I choose any number between these 2 points or what?
No, you choose any two numbers on the line.
I mean on here, the whole thing. Like,
So,
like in here he took like 1.0 and here he took like 0.7. And here he like took it from the x-axis like this one. He took like
no,
1
no,
point.
no, no, no.
Or what?
On the graph. You see the straight line?
Yeah.
Yeah, you choose 2 points on the line.
For y-axis.
No, on the line.
I'm seeing here and at this point he just took this dot here, yeah?
Yeah.
At here is like let's say at y this is y2, yeah?
Okay.
1.0 is like here is 1.0 and here is 1.6, for example.
Okay.
And he took this point which is like 0.7 at y and
Yeah.
0.6 at x, like this, yeah?
Okay.
And
Okay.
that's it, yeah? Then you just get your slope. That's
Yeah,
what you get.
correct.
Okay. y2 minus y1 over x2 minus x1, you just make your graph and then plug in the numbers.
Yeah.
minus 0.6 is equal to 1.2 mt over a, which is equal to 1.2 times 10 power of negative 3 t over a. Okay, then discuss scattering is low scattering, precise, accurate, and is proportionate to the and is proportionate. Precise, random errors are minimum y intercept equal to 0 and what y intercept equal to 0, no sympathetic error, and y equal to 0, no scattering, no. Bro, my friend got like these two. He got the first two experiments. He got the what's it called, charge per electron,
Yeah,
and he got Ohm's law. These
that's
are
good.
like the easiest ones, or
Yeah, that's easy. Lucky guy.
yeah, but he got the he was like standing in front of the doctor.
Uh, I mean, it's okay. You cannot cheat either way.
No, that's the thing. And the slope determine the value of MO and compare it with the real value MO is equal to correct. You mean the real value?
Yeah.
This isn't this like the compare the real value? This is not percentage error. This is different. Difference.
What?
Difference percentage difference.
Which
Find
one?
the slope, determine the value of MO and compare it with the real no. Don't you see the screen?
Hmm. Yeah.
B is equal to MO and I R squared. This is like I think equation we studied for physics. One of the stuff. Remember BL is equal to mu 0 and I R squared
Yeah.
over 4 pi R. No, 2 pi R. This is the notes that you had for your high school.
Hmm.
Yeah, I remember
Yeah.
it was like R cubed.
Yeah.
Bro, what did Balaji tell you? Was he with you at school?
No, he was not with me.
You guys know too much about each other.
Yeah.
Okay. From the slope, determine the value of mu 0 and compare it with real value mu is equal to 4 pi x 10 power of negative 7 and is equal to 200 10.5. Wallah bro, I've been having the weirdest dreams, swear to God.
What dream?
Well, every dream is like related to like studying something about study.
That's good. That means you're focused.
Bro, not focused, panicked. It's not like studying. It's like I'm suddenly I'm in the exam. I'm like trying to solve an
Ah,
equation, and like looking around like something, and I wake up suddenly confused. Weird, weird
um,
emotion. Oh, it's so bad.
yeah. It's okay, bro. Only one more exam. Do you have any other exams after tomorrow?
No, I will have engine 112, 211. I mean, and that
Yeah.
with you. What's it called?
Okay, that is on December 4th sometime.
Okay, this is percentage error. Yeah. Percentage
Yeah.
error is. Will they tell you like in the quiz like what's the percentage error? For example.
No,
Hmm?
no, they did not tell you.
They won't tell you to do it. How would you know?
No, they will tell you to do it. You have to do it by yourself.
I'm saying, will they tell you like what's the difference error? Like, what if it asks you like what is the difference between the compared
No,
this
no,
and
they
this?
won't ask you that.
That means will
They will tell you only to find. You have to figure out if it's percentage error or percentage difference.
then do it both.
Huh?
Do it both.
Yeah, do both.
No, I mean like if it's asked what is the percentage error, not I mean if it's like it's saying what do you use? This guy will write both
Yeah, to be honest, you can do both.
because experiment different what's it called percentage error is equal to what? It's just x experiment minus x real over real and then multiplied by 100.
Yeah.
And the difference is what? It's just x2 minus x1 over x2
Mm.
plus x1 over 2, and all
Yeah.
multiplied by 100. This will give you the percentage difference.
Yeah.
Oh God. Zero point two seven percent, 27%. Bro, like I have to finish this exam, and Monday go to the doctor's office. Ask him if he can like at least help me a bit if I did bad, you know.
Mm. Yeah.
Please, if you can like increase 1 point or like let me do something. Because bro, and the other stuff like the other, do you go to their office every time?
I
For
never
like
go to the office.
okay, but that's my problem. I also don't go.
Hmm?
That's my problem. I also don't go.
Yeah.
I should have went at every office hour. Just have no time. Bro. I just feel too tired.
Mm. I see you all the time going to the professor's office.
Najib, only Najib.
Yeah.
That's why inshallah I'll pass. And Najib will be kind. I mean, he is the
Yeah, he'll
best
be
one.
fine. I
Wallah.
think everybody did bad for this matter.
Bro, you didn't hear everybody laughing as soon as
Yeah,
they
no, I
saw the
heard, I heard.
question.
That's what I'm saying.
In the exam, how many proctors were there? Like 11?
For the lab,
Yeah.
only one.
Why only one? Why don't they bring like four, and
Yeah,
then
why not bring the whole,
use the
why not
security?
bring the whole
You know
faculty
the
there?
Najib's security thing to find any smart one.
Bro, Najib's security is crazy, bro.
Bro, because last
Bro
semester they
had
cheated
all
so
four
much.
guys. Yeah, he got mad, I think.
I know he accused me too last
Yeah?
semester, but then what? I thought I did. He sent me an email like you failed the third midterm, yeah. And I went to his office. He said you
Okay.
didn't fail, but you got a good mark. I said really, but he said I want to see if you know how to solve this question. Bro, did he wait before I tell you the story? You see, this is a mistake, yeah. Like percent error is like this, yeah.
What?
But percent difference is like this. Why did he write both of them as error?
Let me see.
Do you see my screen?
Sure?
See this and this?
Yeah, it's wrong, it's wrong.
Yeah, this is supposed to be difference, yeah?
That's wrong.
That's supposed
Yeah,
to be
correct.
difference. Okay.
Yeah, yeah. That should be percentage difference.
percentage difference, which is x2 minus x1 over x2 minus x1 over 2 times 100, which will give you like some number. Discuss. But what is this B what? B hung, thung, height, device,
Hmm?
formula? What is this?
No.
B measure, B what? B theory?
Where is it?
This one, don't you see my screen?
Ah, yeah, that's B theory.
B theory. Well, I'm gonna write a theory middle of the exam.
Hmm.
Our theory is
You have to
always
just
correct.
write the
Like,
formula, that's it.
our theory is like always correct or no? Like in physics.
Theory is not always correct, as in, if you do the wrong formula, then you're cooked.
Mm. Hey, stop saying cooked for once. Eh?
Yeah,
already,
sorry, you're not cooked. You will cook.
I'm already. No, I found this image. I'll show you.
What?
I found the photo.
Of who, bro?
This photo here. Look at it.
Hey, yeah, what the
No,
fuck?
I will make you understand it. You see the cook, yeah?
Who is he? He's some Chinese dude.
I will show you what I mean. This is basically like my life now. I'll show you. Wait, how do I? Wait, yeah.
You're getting cooked, that's what you mean.
This is the meme. You know, I remember this in the exam. I know my set. Okay, you see the shit, yeah?
What?
Wait, where's
Yeah.
the pen? This was like me first semester, 2024 after the army. Me and like
Yeah.
and my this is like imagination, huh? Imagination.
Yeah.
This is what engineering, huh? Electric engineering. This was like 2024, yeah. And
Ah.
then 2025 is this me and electric engineering.
Ah, nice,
Oh
nice,
god,
nice.
I
Funny,
wanna
funny.
cry.
Bro is getting cooked, and then bro was cooking.
Bro was never
Yeah.
cooking. Bro gave up.
No, never give up.
If I can open this in the exam, I think I'm good. Oh god, I don't think I have the mental capacity anymore.
No, like, one good thing about you is you never give up.
Bro, I
That's
never
good.
give up, but I keep on failing. That does not mean I'm doing well.
Yeah, that's called persistence. I admire that.
But my
Like,
allowance,
not many
bro.
people can do that.
Bro, I should have left
Many
like
people.
last semester, but I didn't. You know why I'm glad? Because I met someone like you.
What?
I'm glad I didn't leave like this semester. I was gonna leave US because I had like
Yeah, you shouldn't
problems.
leave.
Bro,
Why would you leave? Look,
bro,
that's
it's
what.
been hard, bro.
Your persistence is what kept you staying. That's why I said it's like a rare thing. That's why it's good that you have it.
And you know what's
Not
also
many people
annoying?
can do
You know
that.
what's also annoying? Like I calculated my
Yeah,
grade, yeah. Like I'm not doing that
yeah.
well. Like my GPA is like 2.3, I think. It's not like that good, yeah.
So okay,
And that
you can
problem, you
get it
know.
up.
Yeah, I know I can still make it up, but you know what's like weird? Like I
What?
calculated my grades, yeah, this semester, and I
Yeah.
said I checked it. You know, if I get under 2, I lose my scholarship. under 2.
Yeah, I know.
And I calculated the worst grade possible. Like I failed physics 2 lab, I failed physics 2, and I fail engine 2
Yeah.
11. I calculated that grade, but
Oh,
I passed
okay.
I passed English, like writing 102. I passed it like barely.
Hmm.
Not barely. I mean, I
Okay.
passed it as B plus, and my other subject that I'm already doing very well in is like Arabic. Like I put it also B plus,
Yeah.
but I'm expecting A minus or A. I just like put the minimum grade, and you know how much it was? It's
What?
wait, let me show you. It's I think I have it here on ChatGPT. Where is it here? You see here? Actually, I put the worst grade ever, the GPA. Look at how much it turns. It's still over 2.
That's
So
good.
no,
That's very good.
that means I can still have a chance. But bro, I'm fed up. I'm already like,
Yeah.
Allah, like I reached a point, like mental state. It was bad.
Hmm.
And
No,
then
but
still,
like
I still
even
have
in
a
that
chance.
case, you keep going on. Yeah, that's what's good.
Sad, bro. I
No,
remember I saw a
I
video.
admire.
Oh, I remember I saw a video. A girl was like a Filipino girl was trying to give motivation. Yeah, like somebody gave her the mic.
Yeah.
She just said, "If you keep going, that means that does not mean you will make it."
What the fuck?
I was crying, bro. That's so funny.
Who is this girl, bro? Get her out of the stage.
Even if you
After
keep
leaving,
going, that does not mean you will make it.
the fuck? Who's this girl? No, Terry, get the fuck out. Oh, bro. Oh my god.
Okay. I think before the exam, I will just read these notes. خلاص, I don't want to do
Yeah,
the
that's what I
exam.
did.
And then sources of error. Bro, if I want to like know sources of error, can I just like use my brain? Like for example, okay, I will do this lab.
Mm.
Yeah. Let me just
They won't
bring
ask
us
sources of error.
my friend said they asked for it.
No,
Okay,
for me they didn't.
let's say I chose this lab. Yeah, I got Korchev's law. Yeah,
Mm.
and I suddenly asked for what sources of error. Can I just say first the wires, like some ports were not connected properly. There are some issues with like
Yeah, yeah.
power. There could be some issues with the power supply, and and like wiring that is not placed correctly could cause like some malfunctions, and like
Yeah.
hesitancy and like putting the wire fully. Maybe a miscalculation like this. Like they can like write a lot of stuff. You have to be creative with this.
Mm. Yes, you're right.
Okay, I think I finished the last lab. I watched all the videos, and I did.
You done
And I
now? You want
understood.
you have any doubts?
Finished all of these guys, خلاص. And like I can't do anything with you anymore. Like I can't like. What do I tell you? Will you want me to do this? Yani? Go to each what's it called? Yeah, see, this is my grade. Okay, so where is it?
You have any doubts or anything?
Of course I have, bro, a lot. But anyway, what do I do? Is there anything more I can
Ask
do?
me.
Okay, what was the charge
Ask
of
me anything.
electron?
Charge of the electron is remember the copper sulfate one? You take the electrode and you put it inside the water.
Yeah.
Copper sulfate solution. That one. Okay.
So you have like this amount of time, minutes, and
Yeah,
the
they'll give you
RI is
that.
like this, height is this,
Hmm.
mass is given, and then they won't give me this. No,
Hmm.
this one I have to write it by myself. Yeah.
Yeah.
Oh
You have
shit!
to
So
make the table by yourself, but like they'll give you the time.
Oh no, I mean like I. Will they tell you like what's I, what's IT, what's M, or you have to also write them all?
Yeah. They'll tell you what T and A is. You have to find out IT.
You mean T is as in time and I is in ampere?
Yeah, you have to find out what M S M naught is all that.
Hmm. And did you use a similar graph like this? Or
What?
for you, when you did the graph, did you make it like this, similar?
Yeah. I didn't do this lab for the experiment. For the exam, I mean.
Wait, let me bring up the one that you did. You did the Wisdom Bridge.
Yeah. And the RC.
Wait, you have to do both labs. Wait. You know when when you told me like they check your thing. Average grade.
What?
What did he write? Average grade. Okay.
I don't know what that is.
Okay. I'm just saying for like the Wisdom Bridge. Yeah. Did they tell you had two labs? Yeah. The Wisdom Bridge and RC
Yeah.
circuit. Yeah. When your first one
Yeah.
was what? Was RC circuit. Yeah.
Yeah.
So when you finished the wiring, did he come and check? You told him, yeah? You asked him to come?
No, I told you, right? Once I finish the wiring, I have to call him and
Mm-hmm.
he'll come check. If he
You
says
have to
okay,
do
then
for
only I
both.
can
Do you have
proceed.
to do for both at the same
No, no,
time?
no.
Or you have to finish
Not at
like.
the same time.
So you have
You
like
can
four.
finish that one and then do the second one.
No, so after you finish. Wait, so you have to finish a full lab, then you start the second one? Like wiring and wiring?
It's your wish. It's your wish.
No, because I'm asking like. If you want to like, if you let's say you finish
That's
this lab, yeah,
what I
then
did.
you
I
have to you
finished the
have
whole
to.
lab and then I started with the next one.
And when you started the next one, did you also call the doctor again?
Yeah, yeah,
No. No.
yeah.
Okay, so this one was like yours, yeah? Like it asked you from what to what? Like 5 data points, yeah?
Yeah.
So how do you get your RS? It's like this is the load, yeah? That's given.
They'll give that. They'll give
Yeah.
it.
Okay, L1
Yeah.
is what? Is just 100 minus what? Minus the centimeter that we're in?
L1, you have to find that from the graph.
You mean not the graph, you mean this. You mean the board.
Sorry, from the experiment.
Yeah, the board itself.
Yeah, from the board. Yeah.
Plot a graph L1 and L2 versus R2. You also did this? Using
Yeah, but like
Microsoft Excel.
I did it with hand, not with Excel.
Uh,
Not with Excel.
I put this in ChatGPT. L1 and L2. This is L1, L2 and ohms. Versus RS. RS is the ohm. So we started from like 35 and we ended with 120. Okay.
Yeah.
And how do you get L1 in this?
Hmm?
How do you get L1?
That is the equivalence point. You have to put the thing in the Wheatstone
Yeah,
bridge,
okay, so I
and
have.
whenever the V is zero, you get that.
Yeah, so like I got this first.
Wherever
These
it is
these
zero.
are all my centimeters, yeah. And L2 is basically what? It's
Yeah.
L2 minus 100, yeah. L1 minus 100 is L2.
Yeah. Correct, correct.
Like see?
100 minus L1.
Yeah, okay. And L1 over L2 is what? It's just like this guy, this guy. Okay.
Yeah, just
And then
divide it.
this is just the graph. The slope is what? Is just
Yeah.
I chose 2 points, yeah. Y2 minus Y1 over
Slope is, you know, the
X2
x2 minus y2 minus y1 by x2
yeah,
minus
yeah,
x1.
yeah, like that. And then let's say I chose a point y2. This is my y2 and this is my x2,
Mm.
yeah. And then I chose a point here. This is my y1.
Yeah.
This is my x1. And then I just chose it, and this is the
Yeah, correct,
x.
correct.
This is the slope. I mean, I got. But the y-intercept, how do you get it?
There's no y-intercept, don't worry.
No. How do you get a y-intercept? Like let's say.
That you can only get if you get with Excel. But you're not using Excel, so it's fine.
Okay. Okay. So use the slope of
Yeah.
the graph to calculate Rx. Okay. So I got my slope. I mean, no. Oh, Rx is just like.
Yeah.
Did they ask you this also? Yeah.
Yeah, yeah.
Okay, so Rx is just what? It's just 1 over slope?
Yes.
1 over... No, it's just your slope that we got, but over 101, yeah? That's it.
Yes, yes.
Okay, so this is what we got. And
That's it.
determine the value of Rx using the color. So let's say our color was what? Gray red. So gray red is what? 82 times 1 black. Then what? It's gold, yeah? It was, I don't know if it was gold or something, but that.
Mm.
So then
Yeah.
we compare this with what? This one with our with the experiment. So what? So like 82 minus our experiment over this. Yeah, over the real one. No. Oh, I think
Yeah.
that's my mistake here. I flipped them. Or no? Okay,
Go
what I
down.
mean is basically the experimental. The real value is our value, yeah?
Mm.
Or experimental is the real value,
Mm.
huh? You
Yeah. No, it's correct. It's all correct.
wait. So real value is my value, huh?
Real value is not your value. Real value is the value of the register through the color code.
Oh, so I made a mistake here.
Yeah.
This should have been 77.5
It
minus
doesn't matter
82
because it's
over.
absolute value. It doesn't matter. It doesn't matter. Bro, it doesn't matter because it's the
Yeah, but
absolute value.
it should have been
The minus won't be counted.
it should have been divided by 82,
Yeah, yeah.
not 77.5. Okay, yeah, that's my mistake. I have to fix this. Okay, so
Oh,
uh,
yeah, yeah, yeah,
yeah,
yeah.
so okay, so the value
That's
is
a
what.
mistake. That's a mistake. You're
Yeah,
right.
yeah.
You're right.
But I don't know why he didn't just like he didn't mention it. He didn't put an X.
You just got lucky. Don't worry
Okay.
about it.
Yeah. Okay. So this. So basically, it's just saying compare the values. Yeah. It didn't say like what's the difference. What's
Yeah,
the error? So compare the value is what? I mean, no. Compare the value is error. So what? So
yeah,
write our what? Our experimental minus real over real times 100. So experimental is what?
yeah,
77.52 time minus what? Minus
yeah,
82 over 82 times 100. We'll get this some number. Okay, so
yeah,
it says discuss. Yeah, we got this percentage. It's less
yeah,
than 10, so it lies within this range, and it's like reasonably accurate and like that. Okay, discuss my
yeah.
graph. There is scattering data.
No, no,
The
they won't
white.
ask that. They won't ask that. They
They
won't
won't
ask that.
discuss your graph.
No, they won't ask that. They
Okay.
only ask discuss your results.
Okay, if they ask, or just say
No,
it's
I
minimum.
had this. They didn't ask it.
No, for me, if they ask. Okay.
Okay.
Calculate the value of unknown resistor. Okay.
No, they didn't ask this also.
Then ask for this.
No, they didn't ask
Just
this.
calculate the standard deviation.
No, no, no. They didn't ask all this.
Oh, so only like half the part.
Yeah.
Okay. Let's go to the second. Let's go quickly to the first. First, I will go. You
The
know what?
RC?
Let's quickly go through all the labs and like yeah,
Yeah, okay.
and just like understand how to do them all.
Mm.
Okay. So this is with Sufyan. I think you know the guy. Okay. So
Show me
first.
his photo, Sophia. Because, like, I've been seeing him, like, everywhere. I don't know how. Like, what.
Yes, I
Zoom,
see
zoom.
the guy everywhere.
Oh, he is Sophia.
This guy.
Yeah.
Okay.
Okay, I don't know.
If you see, maybe he's on. So that's the thing. And equations, did like you need all of them or what?
Equations, what equations?
Like see equations
For
here.
the.
We only did
Uh,
we use this? We need I think this.
no, no,
That's
you
it.
need all of these if you're doing all the labs.
No.
Don't look at this, though. This is complicated. Use the notes that he gave you. That's easier.
Okay. Okay, let's do this quickly. We'll do like this. Huh? I don't want to write anything more down. I want to like use memory. Okay, so
Yeah,
this
okay.
is the clamp. You'll have what? You'll have an experiment, yeah? So
Yeah.
wait, let me just read it to myself here. Because I wrote everything down to you in the messages. So experiment one, we have a power supply, yeah? Multimeter thing. We'll use
Yeah.
one wire with a multimeter. We'll bring it where? What's it called? Yeah.
Excuse me.
Power supply.
No, there's no multimeter. Wait, there is.
No,
My
there
bad.
is.
Yeah.
There is no experiment with without multimeter, I think.
Hmm.
Put it on the power supply.
But
First
technically, you
voltage
don't
side
need it.
negative, then add, then the multimeter is put on.
But of course, in the lab, you have to show it.
Okay. Let me just do something quickly. If I want to make progress, I think I need to do this. Wait. So first lab, I will just draw it quickly. Yeah?
Your
I want
circuit
like,
diagram
Yeah, yeah,
is
you
yeah,
do what you have to do.
basically had a
I
power
told you,
supply,
bro. I'm here to help you. You can just do what you
power
want.
supply. It goes on to the ammeter, which is connected in.
Yo, bro.
Hmm.
Tomorrow is the submission for the English essay thing, right?
Yeah, it's like tomorrow at 9.
Okay, bro. I need your help for that, bro. Please, yeah.
Sure, bro. Yeah. After
Yeah, I
I
don't know
will
what
be.
to.
I think I'll finish uni at like 5 maybe,
Okay.
because I will finish my
And then
lab.
what
You
time
know.
will you come home?
I'll be like
What time
there.
will you come home?
I'll be like there, like at 6:30. I'll be home. You know. So we'll just
Okay.
we'll just like send you everything, or just join a meet. I don't mind.
Okay, okay, fine, fine, sure. So what is the essay on? It's on, what is the essay on? I
The
forgot.
essay is like impact of social media on your
Yeah,
on academic performance, just like that.
on academic performance. Okay, fine,
Yeah.
thanks, thanks. Got it.
Electron. Okay. So you basically have what? You have a multimeter.
Yeah,
Just say you have a multimeter. And you have the four ports of the multimeter.
In series and from the
yeah.
I call this M1. I call this M2. I call this COM, and I call this V2 basically.
ammeter, it goes to one of the electrodes.
Yeah. Okay.
Professor, we have it controlled, right?
Okay. So you have your thing, and you have your like two wires. Yeah.
Yeah.
They have two plugs. These guys, and both clamp into what? Both clamp into the copper. So you'll take your power supply. You have minus encircled and positive. You have the volt, ampere, and like something in the middle, which is called, what is this? Fine. Yeah. Okay.
Is there some event tomorrow?
Think so maybe. I don't really care.
What event?
US, bro, you know events every day, but you don't have time for the events. Like, well, like they expect an electric, like any engineer to
Sorry?
be
We
there.
have this one.
You'll have the circuit diagram, yes. Sir.
Yeah.
Let's try to follow that. And from the other electrode, it goes to the negative
Okay.
of the power supply. So this is my negative electrode, which is the cathode, and that goes to the
This goes to the negative. Yeah.
negative of the power supply, right? So you just clamp it. Now these electrodes have to be dipped into this copper 2 sulfate solution. So we lower it.
And you make sure that it's touching up.
Yeah, and we make sure it's not touching from the sides, from the base, and try to lower it as much as possible, right? Not too little, and also not too much that it's difficult for you to take it out. It's kind of covering sensible amount of area. So this is your connection. Positive goes to the ammeter, because you need an ammeter in series. From the COM of the ammeter goes to the positive side of this, which is the anode, and then the negative side goes back to the cathode. Right? Yeah.
Should we not avoid the...
Yeah, I'm just doing the connections now because I want the current to be set, and once the current is set, I will switch off and then I will get my M0. So what was the current in this case? We said any value between a particular range of 0.4 to 0.7 amp.
0.4 to 0.7 amps. Okay.
So this is going to be used as a current source. What do we do if it's going to be used as a current source? So we maximize the voltage, set the current
Max.
to something between 0.4 to 0.7, right? So this is my ammeter now. I will set it to 20A, and I have a value of, let's say, 0.3. So set. I can switch this off. Do not change the knob. So your current is set. Now you're ready to take the mass, and that will be the mass, the initial mass, M0. Which electrode am I taking? The negative one, the cathode, right? So please remember the cathode is what we are taking because the mass is being transferred from the positive to the negative, and each time the mass of this electrode is increasing. So consistent and because sometimes you take mass of this cathode. So initially, when there is nothing, make sure it reads 0, and then you get the mass. Of course, this is and you get
Okay, and you have a timer, yeah? And you have like for how many events did you get? Or no, you didn't do this, yeah? Timer
Oh, which one?
and events, yeah. This one, this is the lab, the first lab.
Yeah. No, one second, I'll be back. I'll just get some water,
You
okay?
take your time.
get ready with the timer. Once you start, we will basically wait until whatever procedure is telling us. If it's 5 minutes, 7 minutes, 10 minutes, whatever, follow the procedure. Once that time is over, you switch off and you repeat this procedure, get the mass of the kettle. And if you recall, again, you have your lab reports, you just recall you're getting the change in mass, delta M, and that is what you're plotting to get your charge of the electron. So look at your lab report and see what you do. Get the change in mass, the delta M, from voltage. We were doing it in two parts. The first part had this 1 meter long wire. Check if it is ohmic or not. We will apply some current and goes on to an ammeter. Ammeter is the negative. So for voltage, we were doing it in two parts. The first part had this 1 meter long wire. Check if it is ohmic or not. We will apply some current and apply some voltage and look at its current. Is it increasing, decreasing? How is it functioning? So the circuit diagram. How was the circuit diagram? From the positive power supply, it goes on to an ammeter. Ammeter is connected in series, and then to the wire, and then there's a voltmeter connected in parallel. Right. So let's start. Positive of the power supply goes where?
To the
And then positive of
V nine negative ampere.
of the power supply goes where?
into the amp.
Into the ammeter. For safety, we said we always start from 20, and then from the amp, which is the COM, it goes to that 1 meter long wire, which is here. So this side supply is connected in series, and then to the wire, and then there's a voltmeter connected in. Of the power supply goes where?
Into the amp.
Into the ammeter. For safety, we said we always start from 20, and then from the amp, which is the COM, it goes to that 1 meter long wire, which is here. So this side and then from the other end of the wire, where does it go?
Back to the power supply.
Back to the power supply, to the negative of the power supply. Then I have a voltmeter connected in parallel to this wire. So the positive, the V terminal, goes here, and the COM terminal comes here. So now I have a voltmeter connected parallel. I have an COM terminal. The V terminal goes here, and the COM terminal comes here. So now I have a voltmeter connected, and the COM terminal comes here. So now I have a voltmeter connected parallel. I have an ammeter connected in series, and I will note down the current values as I change the applied voltage. Verify Ohm's law, and values as I connected in. So I know V is equal to IR, or R is simply equal to report. Notice that you did it for different values. Just do it, repeat it, and confirm if this wire obeys Ohm's law or not. Right. So in this case, what did we do? Switch on for some particular values. We'll get the voltmeter here. Yeah. So 5 values, right? Any 5 values. Now in this particular experiment, your current values are going to be small, so you can safely shift this to the milliamp range, and you can then change the range and see whatever those corresponding values are. So get any 5 values. So let's say 1, but the only thing you have to take care of is you do not exceed 200. So let's say 1, 2, 3, 4, 5. So any 5 values. The only thing, just make sure do not exceed the 200 milliamp in the ammeter. For those corresponding 5 values, you have different 5 voltage. So get the voltage values from here, from the voltmeter, the current values from the ammeter, and get the resistance of this wire. Okay. Questions clear? Just look at the report, see how it was done. You are also finding the resistivity of this particular wire. You are comparing the resistivity with the real value by finding the percentage error and checking its accuracy of the data. So corresponding voltage and current values. Now it's done manually. It's off. We're connected in series and then in parallel. So let's say, let me just switch this off. When two resistors are connected in series, just use this gap. Of course, what's the value of this resistor? No. From the color code, so just make it there. This is one. This is two.
What the hell happened? I don't.
Basically have voltage. These are connected in series. Just use this gap. Feed the 200 milliamp and the ammeter.
Yeah.
Yeah, I'm back.
Check.
Did you do it?
Hmm?
Did you do it? You done?
No, like doing the third tab, but let me just quickly go through it with you here before I write it. Okay.
Yeah.
So we're like we just finished charger and electron. Yeah? Oh, no, what we did the Wheatstone bridge.
Yeah.
What did we do just now? Wait, just give me some. Okay. Just want to go through the chart.
9 out of 10, that's good.
Huh?
You got 9 out of 10, that's good.
Bro, Safyan carried. Well, that's the only 9 out of
Safyan.
10, bro. It's nothing else. Okay, so this
Safyan.
one is the time. It's just how when we clamped it inside the thing and then we dry it and then we put it. Our eye is just the ampere from the machine, yeah, from the supply power
Mhm.
supply.
Yeah.
And
What
the
else?
C is what?
Okay, I'll explain it to you, okay? So when you do this experiment, basically all you have to do is you have to connect the circuit according to the circuit diagram, and then you have to put in all the electrodes into the copper sulfate solution and all that. And then once you start the timer, you wait for a certain time, and then you take the electrode out, the cathode, very important. The thing connected to the negative, you take that out, and then you weigh it. And then before that, you should have taken like the initial mass of it. That's the M naught, all right?
I'm
And then
not
you
just no,
subtract
wait. I'm
that
not. I'm
from
not.
the.
Do I put the wait? What's it called? This is not the M node. This is what? This is after
No,
like
that is not
4
M
hours.
naught.
Yeah.
M naught you should
M
take
node is
initially
the beginning.
before
First.
before the beginning of all of
Before I
everything.
put everything. Yeah. Before even I put
Yeah,
it in water. This is the thing.
correct. Very good.
Okay.
And then you subtract the two, and you will get delta M.
M
So then
node
after
is
that,
just
you should form a graph between IT and delta M.
IT and
Go down.
delta.
Yeah, look, delta M is in the y-axis and IT is in the x-axis.
This is C.
Okay. IT is basically C. It's fine.
Okay. No. Okay. What I wanted to know here. Oh, what if the paper got cut? In my book. Okay.
What?
No, I'm just saying I have this experiment one, and like the laws and rules I wrote down, the paper got cut by accident. It's okay, no.
Yeah,
Okay,
it's
so
okay.
mu naught is before anything I take the mass, beginning.
Yes, correct.
Okay,
M naught,
so,
not mu naught.
M naught, yeah. So
Yeah.
time is what basically the first one.
What?
I mean the time is the like amount of time I put
Time
in
is
this
given, I
equation.
told you. Time and current are given. Don't do anything with it.
Oh, so you don't even calculate? No, you mean, bro, you have to count the time. Like put it in. I have a timer. Of course, they will tell you.
Yeah, of course, you have to put the stopwatch, but I'm saying don't do any calculations. All you have to do is
Yeah,
multiply the time with the current. That's it. Simple. It's already
time
given
with the
everything.
current. You
Huh?
mean which is where is the current? Which one? The one
Current
that I
is down.
got.
Look, 0.5, 0.5, 0.5, 0.5, 0.5.
This one, which is
Yeah,
wrong on the doctor's point of view. Record all digits minus 0.5. No, record all digits.
no, that's the marks you lost. Minus 0.5 marks.
Yeah, that's why he also he wanted to joke 0.5. He lost 0.
He thought he was funny.
And he put like 3 dots. Yeah.
Oh my god.
Okay, so units. Ze- This nigga, Allah. Okay.
Oh
The
my
graph
god.
will make easy to draw reading the documents.
Mm.
I mean, he took how many points? Yeah, he took one whole point.
Yeah.
Write the names. So he didn't take any marks. Nice. Okay.
Yeah.
But we don't care about this. Let me check the stuff now. Why can't I not
Mm.
scroll down?
Then go down. Go down, down, down.
I can't scroll. It's weird.
Down, down, down.
Oh god. Okay. No, wait. Before I go down here, I want to know how to do each. Okay, time is just like the time amount of time I count, and I
Yeah.
is what? What is the count? The count
Okay,
is
remember this, yeah? When you're using the stopwatch, like, do not stop at like 420. Like, say, for example, you're waiting for 420 seconds, and after 420 seconds, you put it to zero and start all the way from 0 to 840. Don't do that. So once you stop at 420, you pause it there, and then you resume it. So, like, when it reaches 840, again you pause it. Okay, so never reset it. That's important.
What do you mean?
Okay?
Like the time? You mean?
Yeah, yeah, stopwatch.
Okay, so I don't reset it, but what? But don't I pull the thing?
Yeah, like say for example, in my first slot, I'm waiting for 420 seconds, and then after 420 seconds, I'm going to pause my stopwatch, and then I will take my electrode out and I'll weigh it, and I'll write the value down, and then when I'm putting it back, the second I put it inside the solution again, I'll resume my clock, so it'll start from you won't start from zero again. You should start from
So you don't
420. So
reset. You just stop.
yeah, yeah. So it'll become
Okay.
421, 422, 423, 424 like that. Get what
So
I'm
it's
saying?
basically it will go not from 420 to 840. No, I mean 420 to 840 basically, and
Yeah, correct.
not wait again like again from 1
Yeah,
to 4.
yeah, yeah.
Then you
No,
have
wait
to
again.
calculate the time again.
Yeah, you have to basically pause the time. Understand?
Understand.
Yeah, good. Don't forget that. That's very important. Many people
Okay.
make that mistake.
Yeah. So first is like first 420 seconds, and how do
I
I
have a
get
strong feeling.
how do I get A?
I have a strong feeling that you will get this one.
Inshallah, if it's easy.
Yeah.
Okay, so IA is equal to what?
What?
I, which is current, equal to 0. How did
Yeah.
you get 0.5? From where? From the power supply?
0.5 they'll be given. It's given. It's given on
Given.
the
Okay,
paper.
so
Yeah.
it's telling you like each minute is this current. You put this amount of current.
No, no, current is fixed. You cannot change it.
Okay, so this is correct. Oh, 0.5, 0.5.
Yeah.
What is he minus then? This guy is so stupid. Okay.
Or no, some small difference might have been there, like 0.56 or something like that.
Okay.
You're supposed to write three significant figures. Yeah, you wrote only one.
My guy, he wrote it. He did not give it in. Okay, so and the IT is the current. How did you get the current?
Current is there in the left. I mean,
What do you
just
mean?
multiply that into the time.
You mean A times S?
Yes, correct.
Okay, so current, how do you get it? Is A times. I mean, no,
No,
I
no,
mean.
no. That is IT.
Wait, I think I
Hello.
made a mistake. I was just reading. My bad. I just like stayed silent for a second there.
Okay.
Time S. And this guy, this guy, this guy. 420. This is what? This is we said I, yeah. I,
Yeah.
which is ampere. This guy ITC, MSG. Yeah, okay. So this is, as we said, yeah, 0.5, yeah, fixed. So and IT is the C. How do you get it? The C by what?
See, I told you, multiply time with the current.
Yeah. Let me just write it down.
Either
Hello.
English.
Okay. How do I get the IA? I mean IT. That's just like 420 the times 0.5, yeah.
What?
420 times 0.5 will give me 210.
420 into 0.5. Yes,
Yeah,
correct.
so A times S is equal to it.
Yeah,
A
correct.
times S, which is like 210. Okay. And then same thing with the other one also here, like 840 times 0.5 will give you this.
Yes.
Okay. Okay, and mass is just the one that we get after we pull it out, yeah, and we dry
Yeah.
it and
I
put it.
told you how to do that, right?
Yeah, yeah. It's no after. It's after. It's basically when I reach 420. Yeah, I stop the
Yeah.
stopwatch. Yeah, I know my
Yes.
current. I will write it down. Like I will look at the
Yeah.
machine and see it, and then
Yeah.
at 210. And how do I get to 10? Is A times S. A times S will give me what my IT, which is the current,
Yes.
and the mass is the mass that I get after I dry it and put it. Okay.
Correct.
After this, I know what to do. My stopwatch is still the same. Huh? I stopped it at 420. Yeah? I don't do anything. I wait until now. And now here, delta M is equal to M minus M naught. So basically, what my M that I got, which is like 14.165, minus what?
Yeah.
Minus the original. So this is
Yeah.
it. Yeah. Okay.
Yeah.
So this one is also not given. Yeah. Not given.
Okay.
This is
You
given
have
or
to
not
find that
given?
out.
Yeah. Yeah. Okay. So
You
it's
have to subtract
I
the M naught from
IT
the M you got.
Yeah, so my M note is basically what? Like let's
You wrote
say,
it above.
yeah. Let's say like what? Like 14.165 minus what?
Yeah.
Minus the
You have
original
to
M note.
calculate that before the experiment.
What do you mean?
Like you have to weigh the
Yeah, I know this
cathode
one. This one,
before.
yeah.
Yeah.
0.05. And then all of them are like the same one.
Yeah.
Okay. So after I do that, I will have to, it will tell me, yeah, plot a graph from where to where, delta M versus IT. It will ask
Yeah.
me, yeah.
Yeah. Yeah.
Okay, so my delta M's are what? Are like all of these, yeah? I will have
Yes.
these like as much as they want. Maybe they want 5, 6. Like,
Yeah. Yeah.
I think my friend told me he got this one, 201 minutes. 35 minutes. Damn, I don't want to. He said he got 15 minutes.
Oh. Yeah. It takes a lot of time. That's the problem with this experiment. It takes a lot of time.
100 seconds. Okay. So he only, I think, did until this. What is the thing?
Yeah.
Here. He stopped like third one, I think. Okay, so it's basically delta M and what and ITI, my current. So I will write on the x-axis my lowest point, I will write like at 0, 0, 0, for example. And my highest point, it would be like 320,
Yeah.
0.320, like until here. And then my IT, I will write the lowest one at like 200, and the maximum at like 1,100, for example. Like,
You're breaking up.
huh? Yes,
No.
yes,
No.
my bad.
You're breaking up.
Well, you're also lagging. Okay. Wait, okay.
Yeah.
You see here, yeah. Well, I will make this the highest one. What is we said M, yeah? No, not M, delta M and so my highest, let's say the highest delta M is what? 0.40, for example. And my lowest one is 0, 0. I'll put like here.
Yeah.
We got one at like 0.5. Okay.
Ah.
So this is
Yeah.
our point from here. And then the
Yeah.
x-axis is what? It's just the IT. So IT is what?
Yeah.
It's IT. I thought it was I, my bad. Okay. So IT at 210. Lowest one is like
No, it's IT.
yeah, my bad. IT.
One has to be calculated.
Make them both at 0, and he chose a point. I don't know why he chose 70. It's okay, yeah. But yeah, basically the second
No, that's
point
okay.
here and the
That's
second point here are like ours. Like this point here is what we got, what we have,
Yeah.
and this point here is our original. Okay, so basically we put this the lowest one, and the
Yeah.
highest one we put it like almost the same, which is like 1050, which is what we got. You see how we got here 1050.
Yeah.
Okay, so what he did the
Yeah.
y2 minus y1 over x2 minus x1. Let's say he chose a point here, y2, and over what and here
Yeah.
980. Let's say for example this guy until here became 1050.
Yeah.
No, you have to choose a point that is not
Yeah.
the ones that you have, yeah, but like between them.
Yeah. Correct.
Okay, so he wrote x2
Correct.
minus x1. I mean y2 minus y1 over what? Over like let's say this was the x2 and this was like the x1 here, like 132 1,
Yeah.
this guy. 0.02. This is the x1, x2. No, this is y2, y1. I mean,
Yo, 1 second. Yeah. 1 second.
take it.
I'll be back. Yeah, okay, go on.
X1,
Yeah.
X1 and Y2, X1 and Y1, and
Uh-huh.
X1 and Y1 and
Y2, Y1.
yeah, X1 and Y1, Y1,
X2, Y2.
Y1 and Y2. This is Y. No, wait, what?
X2, Y2.
Yeah, Y2 Y2 X2 and
X2,
here what?
Y2.
Yeah, and X2 Y2.
X always comes
It
first.
does not matter how you write it. It's just like the next step. Okay, that's why I was like confused. Okay, so we got our slope and y-intercept. We don't need this, yeah, as you said.
You don't need that.
Yeah. Okay. Discuss the graph. Yeah. If they said discuss the scattering of data points, and then calculate what. Yeah, this guy.
Yeah.
So calculate the electronic atomic mass of copper. Did they ask you this? Like when you got the 63%?
The formula will be given, don't worry.
Okay, so you write this down. Okay, and then calculate the
Yeah.
percentage error. Percentage error is what? Is the experimental. Our experiment minus what? Minus the real one
Yeah.
over this guy.
Yeah.
And this is the one that's like the real one.
Yeah.
And then we got this, and then we discussed our results. We write them down. And the errors like what? Like the water could be more denser. The water could be like this, or like
Yeah,
there
yeah.
is
They won't ask
hesitancy
all
in
that. They won't
clamps.
ask
And
all
like,
that.
if they ask, yeah. And or
Yeah.
washing and cleaning, quickly, like strongly, it will like remove some copper, so it will change the mass, like this way.
Yeah.
Okay. Finish this lab, and we just do this. I think we just did this, yeah.
Yeah.
Oh no, we didn't do that. Okay. What did we do?
I don't know. Wait, what? Sure?
Which one did we just do? Me and you? Yeah,
Yeah, we did.
We did
Sure.
Wheatstone Bridge. Yeah, we did
We
Wheatstone
already did
Bridge.
it. We already did it.
Yeah, we already did this. Yeah. Yeah. How you get this is like this is given, and
Yeah.
L1 is just L1 is just like the centimeter that you're at. L2 is just
Yeah.
this guy minus 100. This guy minus 100, and this is just L1 over L2. Okay.
Yeah.
Okay, so we're here now. Ohm's law. What the hell? Oh, lab report. Okay, let me just continue the video quickly so I like just know how to
Yeah.
put all of the points.
For those corresponding, do not exceed the 200 milliamp in the ammeter. For those corresponding 5 values, you have different 5 voltage. So you get the voltage values from here, from the the current value from the ammeter, and get the resistance of this wire. Okay. Questions clear? Just look at the report, see how it was done.
But Ohm's law had so many stuff. Look, can you see this?
No. Only half of that is covered.
But the half is also crazy. Look at this shit. R is equal to EVE, G short, show all trials.
Yeah.
How did you get this shit? Oh, this was the machine when we
Yo,
used
one
the
second,
machine. I don't think the second. Yeah, he said the second part is not coming in this. Only first
Uh-huh.
part. Because they said the second part is what you have to use the computer. There's only one part. Okay.
Oh shit.
What?
No, but I just fell down.
It's okay.
And you are also finding the resistivity of this particular wire. You are comparing the resistivity with the real value. We're finding the percentage error and checking its accuracy of the data. So, corresponding voltage and current values. Second part, which was done on the interface, now that is the part we're telling you to know how it's done manually. 2 resistors which were connected in series and then in parallel. So let's say, let me just switch this off. When 2 resistors are connected in series, just use this gap. Of course, what's the value
That's
of
not.
this resistor? You should
No.
know from the color code, so just make it
Naughty, naughty.
This is my R1. This is R2.
Wait, bro, this is R1, this is R2? Because we
Yes,
was like
R1.
speaking, huh?
என்ன சொல்றாங்க?
Two. And in fact, the whole thing is the same when you double click this.
காப்பி பண்ண ஆரம்பிச்சிட்டீங்களா? Good. இந்த மாதிரி சாப்பிட ஆரம்பிச்சிட்டீங்களா? என்ன சொல்றாங்களா அவங்க?
So just to have it there. So what's happening again? From the positive,
எப்படி இங்க இருந்து அங்க போறோம்?
and
என்ன எனக்கு தெரியாது. இது கப்பல் எப்போ? போனது கழிச்சு
in
ஆ?
series, so then back to the negative of the power supply, or one, then R2, and then back to the
அப்படியா?
negative of the power supply.
எல்லாருமே ஃப்ளைட் டிக்கெட் புக் பண்ணிட்டாங்களா என்ன? இதோ உஷா வரல சொல்றாங்க, அப்ப என்ன பண்ண முடியும்? ஆ? வந்துருமா? இல்லைன்னா அங்க போய் கிடைக்குமா ஆன் அரைவல்? ஆ?
My voltmeter is connected in
மிஸ் ஆன் அரைவல் எங்க அதை எடுக்கணும்?
parallel to the two resistors here now. So this is
எங்க
my
எடுக்கணும்
V
அது?
terminal and this is the COM terminal. It's exactly the same, just that now instead of this one is one wire,
துபாய்
you
கூட
have two
கொடுப்பாங்க.
resistors. I will repeat the
ப்ராசஸ்
same
பெரிய
procedure. So
ப்ராசஸ்
for
அது.
different 5 values of the
அப்ப எதுக்கு
voltages,
எல்லாருமே
we
அப்படி
corresponding
கொடுப்பாங்க?
currents. And verify ohms and so also same procedure. So switch this on, 5 values. Any 5 values, let's say 1, 2, 3, 4, 5. So just get the
எனக்கு மட்டும் வாங்கி
values, whatever they
வச்சுக்கோங்க,
are,
நான் அப்படியே
verify
பண்ணிக்கிறேன்.
Ohm's law.
ஆர்டர்
How do you get the
பண்ணிக்கிறேன்.
resistance? That's R equal to.
So this is
Yeah, Rashid, tell me.
Resistance R
Hello?
equal to, yeah. I was just saying when
Yeah, sorry,
he
I
was
was
like,
talking about mom.
hello. He was just saying, I think like
Yeah,
this
okay.
resistor and this resistor, this is R1 and R2, or this is R2 and R1.
Yeah,
Huh?
yeah.
What is R1?
Correct, correct. Yeah.
Huh?
R1 is the first one.
Okay, so
First
this
one, the first one. Yeah.
R2 and this is R1. Okay.
V over
Yeah.
I. So V divided by I, you get the resistance. You do it for
And the resistance is
You
equal
could
to
5 values, you get the over I. So V divided by I, you get V over I. So V divided by
Are you singing? Well, you have to be a singer.
resistance. You do it for 5 values, you get the average. But the
What?
resistance
You
is
have to be a singer.
No, bro, I'm not that good.
for two
Just
resistors
like for
connected
fun.
in series, you get the average. But this resistance is for two
Alright,
resistors
fine.
connected in series.
Finished?
5 values, you get
Wait,
the
I'm
average.
just about
But this
to-
resistance is for two resistors connected in series. So that is R equivalent, so which is R1 plus R2. You will verify that by getting R1 plus R2. That's the real value. Compare it with the
R1 plus R2
Holy shit.
to real value, then compare. Oh,
Guru
it compares
says
error, yeah? Percentage error.
Percentage error, yes, you have to calculate.
No, I'm saying compare.
Compare, what do you mean?
It's
When it
saying,
is two real values, when you are comparing between
R1
two
and R2.
experimental values,
Yeah?
when you're comparing between two experimental values, then you have to take percentage difference. But if you're comparing between like one real value and one experimental value, then you have to take percentage.
Yeah, he was like, you know
experimental
what he
plus
said?
R2. That's the real value.
What?
Compare it with the experimental value you're getting
Compare
What
it
did he
with
say?
experimental value, R1 and R2.
from these calculations.
Yeah, then it's
Yeah.
and you get the value.
percentage difference then, I think.
Okay, so it's just like XP2, I mean experiment 2 minus experiment 1 over
Mhm.
experiment 2 minus experiment 1. I mean
Plus,
plus over 2, then
Yes.
times 100.
Correct.
You get the real values from the color code table which you have over there. Yeah. Something really straightforward, similar to what you have done here. If we ask you to do it in parallel, what do you do?
I always
You
make
do it
silly
in parallel.
mistakes.
Get this
Bro.
resistor
That's my
connected
problem.
here. And of course the connection should be tight, connected there. This is two resistors connected in parallel now. And this one, where does this go? Here, doesn't matter, it's the same thing.
Okay, so he pulled.
Here doesn't.
Okay, so he pulled. What's it called? I call this 8. He pulled the 8 to
Mm.
8 and removed. Not remove. Move 9 to 8. Then move 8 to anyone. Not 8. I mean remove remove the port 2
Pretty much it's the same thing.
to what? Like from here to what? To port 4, 5 or 6?
Yeah.
2, 4, 5 or.
So from the positive goes to the ammeter, from the COM comes here where two resistors are connected in parallel. From there
Reach
goes back to the
Stonebridge,
negative
yeah?
of the power supply. I have my voltmeter now
This is not
connected
Wheaton
in
Bridge, this is Ohm's law.
parallel to these two resistors.
We
Hmm.
just did on Wheaton Bridge.
So you also have a few, that's it.
Hmm?
Same thing.
We just did
Increase
Wheaton Bridge.
different values of the voltage,
Yeah, yeah.
applied voltage, get the corresponding current. Verify.
Okay, so let's go to this now. Okay, so just saw the video. This is the on part 1. Okay.
Yeah.
So first we got our thing, yeah. We plug in the yellow port of 9 ports. We have 2 millimeters. We have our power supply.
Yeah.
Negative to negative to COM, positive no negative to 9. Oh my bad. Wait. Yeah. Amp meter to positive, and then the COM to 1, and then to negative to 9, and then
Hmm.
9 to COM.
Okay.
And this guy to the ampere.
Hmm.
What? I think I made a
What?
mistake. Wait. I'm checking the wiring. There's something.
Hmm. Check.
You put this here.
And calculate your resistance, the experimental resistance.
Oh, let's
In the
see.
beginning, didn't he plug this guy here?
Have you heard the song Why This
To the negative
Collaborate?
of the power supply. Then I have a
Yeah,
voltmeter connected in
collaborate.
Yeah, heard it?
parallel to this
Yeah,
wire,
before.
power supply.
Ah,
Get close to that
it's a
one
good song.
of the wire. Where does it go?
Why this
Back to the power
collaborate,
supply.
collaborate,
Collaborate.
Of the
collaborate.
power supply. Then I have a voltmeter connected in
I can
parallel to
wipe
this
the
wire.
skin,
So the
color,
positive, the B
color,
terminal goes here.
color, heart, black. Ice, ice,
So the
meet,
positive, the B
meet.
terminal goes here.
My future dark. Oh, why this collaborate, collaborate. There's no way you haven't heard that song.
Well, of course I have that. It's
And
years
the
old.
COM
Yeah.
terminal comes here. So now I have a
Used to be
voltmeter
so
connected
good.
parallel. I have an ammeter connected in series, and I will note down the current.
Okay, so
Have you watched that TV show, It Welcome to Derry?
I think before years ago. Don't
It just
remember
released
all
like this year. What do you mean?
Which one?
It Welcome to Derry.
Oh, it. You're talking about Pennywise. I thought you were talking about
Yeah.
another series. There's another series called Diary. You know the Wimpy Kid Diaries? This one I thought you were talking about that.
What?
You know the Wimpy Kid Diary? This old book.
No, not that shit. I never read that.
Yeah, I read it like once.
Yeah, I never had that.
They're like the cool kids only read this. Which is
Yeah, I was not cool.
I was never cool.
Yeah, but like, yeah, have you seen it?
Hmm?
Hello,
Yeah,
have you seen it?
Pennywise? No, I didn't watch that. I think I watched only the first part, not the second one.
Oh, okay. What's your favorite show of all time?
Favorite show? For real, Dexter.
Hmm. Dexter? No way.
Bro, Dexter is just like the greatest show
I should watch
ever.
it. I should watch it.
Boy, like
Yo, give me like a list of good shows.
Bet,
You
bro,
have good taste, yeah?
Sure, bro. I will send you a lot. What's it called? Peacemaker, of course. It's the best.
I already watched that.
I know.
Yeah.
Okay.
Have you watched?
So,
Have you watched Game of Thrones? I already asked you that.
yeah, I didn't.
Uh,
Fully.
have you watched The Flash, Supergirl,
Yeah.
Arrow, and all that?
No, I didn't. It's so hard to watch it. There's like so many fucking stuff.
It's so
No,
good
but,
though. That's the
yeah.
point. Like
Yeah.
so many
And the
crossovers
verse,
and shit.
and I
It's so
think like
crazy.
the verse is dead now. Like it's ended.
Yeah, now it's dead. Now it's dead. I wish they didn't die.
And I
The
don't know why
Barry
they
Allen.
cancelled. I don't know why they cancelled Superman and
Yeah,
Lois. They said it's cancelled or they finished the season. The story.
Superman and Lois is done. It's over. The finale was so good.
They said the one that was cancelled, not the end.
You didn't watch the finale?
No, I didn't. I was
So
like, I wanted to watch
good.
it.
You're missing out.
Okay. Let me. Yalla, let's do this. Then I will tell you a lot of shit.
Yeah.
Yalla, okay. So this is just the first part here. Okay, so
Mm.
how do I get my volts and MA and ohm? And MA
What?
is just V over I. Okay. I mean the R, the resistance, the ohms. Okay. This is given, yeah. I mean this part.
Yeah,
Meter 0.6
that's
length of
given.
wire
That's
is
given.
one. Cross sectional is pi. The other is good. Okay. So V, how did I get my first volt? This is like one of the five digits, yeah. What do I
Yeah.
get? He said like
And I
first
think you
digit
have
is
to
this, second
you
digit
have to
is
find
this.
it out from the voltmeter. Look at the voltmeter and
Yeah.
the readings over there. You have to note it down.
Okay. And the MA is what? This one, the
Same
power.
from the ammeter. You have to look at the ammeter
Okay. So
and you
what?
have to
So we
note
need
down
is
the
this guy.
readings. And
Okay.
then you
So.
find R by dividing V by I.
Hmm.
Yeah,
So
that's it.
MI is equal
Simple.
to MA and volts is equal to this and ohms is equal to that. Ohms. You have to find what? Uh, V over I, which
Yeah,
is like equal to what? Like 12.0, and the first one is what? Like 19.5, and the second one is like what? 2.35. V and
yeah,
V and MA is given. Ohm is just like divide this guy by this guy. Okay.
yeah.
Okay, so show the resistance. Show your calculation for all the trials.
That you
So,
can just do by yourself. That's fine.
so like, what is it exactly? How do I do this shit? I don't know.
Just divide all of the. You know how to find the average, right?
Like, you mean this guy and this guy, or what
No,
exactly?
no, all the R. You know how to find R, right? You know how to find ohm by
Ohm is
dividing V
V
and
over
I.
I. Okay. Okay,
Yeah,
V
that's
and
it.
I.
Colors.
But he, how did he get 0. Oh, what? There's also
What? Ask
1000,
me. Ask me. I'll tell you.
bro. This is just
Yeah,
when he said just calculate the resistance. It's just this guy
yeah,
time. This, it's just they have like five numbers, yeah. It's just this
yeah. Just
guy
divide all
divided by
the.
this guy times 1000. I don't know why didn't you didn't mention 1000
No,
here.
he's doing it times 1000 because it's because you have to convert the milliamps
No, it's
to
not even
amps.
times 1000. It's divided by 1000.
Yeah, correct. It's 10 to the power minus 3, right? So it'll be divided.
Okay, so if I want to get my
If it's in minus,
trials,
then it's divided.
wait. Okay, let me just
Huh?
write the next page.
This is easy, bro. Don't waste
No, no,
time
no,
on
no,
this.
no, no.
Go to the next
I'm
page.
just like I just want to write it down. It's basically for each
Okay.
trial. Trial one is just what? It's just V over
Yeah,
I
yeah.
divided by 1000, which is equal to
No, no,
like
no, no, no.
oh,
V over I. And then if you want to convert the milliamps to amperes, you multiply the milliamp into 10 to the power minus 3.
which is 1000. But we don't need it.
Yeah.
We don't need to do this.
No, you have to do it.
Okay, then خلاص we'll do it. Then just do it and get the number that you get. Because I think if I write it
Yeah,
in the calculator, I will
yeah.
get what? I will get like let me just write 0.235 over 19.5 divide by 1000. You'll get 1.2. What? I didn't get 12 amperes.
That's because you divided it. Sorry,
Okay,
you multiplied it.
yeah.
You divide it.
If I don't divide it, I would get 0.012.
No, multiply, bro. What the hell? Look,
Why did we write
do this,
divided?
okay?
Did we make a mistake then?
Do this, do
Yeah, yeah.
this, do this.
When I wrote 12, I got like something similar to this.
Listen to
With
what I'm
times.
doing. Listen to what I'm doing.
Uh-huh.
Put 0.235
Yeah.
divided by
19.5.
19.5 into 10 to the power minus 3. Do exactly as I say. You'll get it.
10 to the power of minus 3.
0.235 divided
I
by.
got 1.2 times 10 power of negative 1.
Let me share my screen. Stop sharing. Can you see my screen?
Hmm.
Do this. 19. What is the value? Tell me the value of V.
0.235.
Wait. Go to calculator. Calculator. Scientific. Yeah. Can you see my screen?
Yeah.
Okay. Tell me what is. Tell me what the value of V is.
0.235.
0.235. Now tell me what the value of the I is.
19.5.
Milliamperes, right?
Yeah. Point 0.5.
Okay. Now to convert this into amperes, I'm going to multiply it into 10 to the power minus 3. Okay, look what I got.
Or can I not just
Look what.
multiply it by 1,000? I think that's better. Okay.
No, 1000 is different. Minus 3 is different. 1000 is 10000.
Then why
Sorry,
did I
one
get the
zero
same?
zero
Why did I
zero.
get the same number
I don't know, bro.
then? Bro,
Oh, it's because
when you multiply it all by 1,000, you still get
Oh,
12.0 by
okay,
1.
okay. I know why. I know why. I know why. I'll
Still
show
the
you why.
same answer.
Look, it's because what you're doing is,
Hmm.
this is what you're doing. Yeah, you're doing 0.235 divided by 19.5, right? And I told you to divide this by 1000 or multiply this into 10 to the power minus 3, right?
Hmm.
So when you divide this by 1000 to 3, which is basically 10 to the power minus 3 over here,
Hmm.
but I'm doing it like this will go up. So then I'll multiply over here by 10,000. That's why this
Okay.
gets cancelled.
Okay, so this
You
one
get
is
what
just basically like this.
It's the same thing. It's the same thing.
Okay, after you get your trials, you'll get a number, yani. And then after you
Yeah.
get like your T1, T2, 3, 4, and 5,
Yeah.
you'll get a number. Then you take all that numbers, all of them over what? All of them here.
And then you multiply it by what? Say again?
Take the average. You see, you just get
Yeah.
like T1, T2, T3, T4. You'll bring them all. This guy, the R, the average of the R, which is like how much? Like let's say all of them. We'll put them all together, and
Mm.
then over what? Over 5,
Okay.
which is what? Epsilon R. Okay. T1, T2, T3, T4, T5. Divide by 5, and let's say we get our average, yeah? It's
Yeah.
11.92 ohms. And then it's saying from the value of resistance, conclude if the wire under test is ohmic or nomic.
Mm.
What is this?
It's ohmic. They won't ask all this though.
Okay, it's ohmic. We'll just say that because that and that and this. Okay, calculate the average resistance. Average
This
resistance?
they won't ask. No, 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 no. This they'll ask. This they'll ask. The part two they won't ask.
I mean, it's literally the same thing here. You just
Mm.
put all
Yeah,
your
yeah.
resistance. Okay, so the second question is just like average of resistance again. So is what?
Mm.
Is all resistance, delta resistance over 5 is equal to this guy, 11.92 ohms.
Yeah.
He took a mark here. He wants us to write this shit. Nigga, shut up. And the other is okay. So, using the value of resistance length and
Mm.
cross sectional area of the wire, calculate the resistivity P of the wire. So what?
Yeah.
So P is equal to
So
R.
just use that formula.
You will give us this.
Yeah, he'll give it. Oh no, just remember it. It's easy.
So what is it? R times A over L. What's L? At
Yeah.
this,
L is the length.
is it given?
Yeah, it's given.
Yeah,
No, you
here,
found it. Look.
1.0.
Yeah.
So R is what? What was our R? You
Or
wanted the
you just found out
average?
right now.
11.92.
11.9.
Yeah. Okay. So and then the
Yeah.
third question is just like P. Yeah,
Mm.
resistivity P.
Mm.
So it's equal to what? P
Yeah.
power is equal to what? To P times
Not
R
resistive power, it's
times
resistivity.
resistivity. Yeah, resistivity P. R times
Yeah.
A over L.
Divided by L.
So R
Yes.
is what? R is 11.92,
R
and
is the
A is what?
resistance. A is the
A is
area.
the area, which is
Yeah.
also
You calculated it there. Look.
pi. Huh?
You calculated it above. Look. A.
Where? I mean this
Go
guy?
up. Go up. The one above that. Look. Part two. Part one. Cross sectional area. Look.
Where? Here you mean?
Above. 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 Cross sectional area.
Oh wait, we did it wrong. How do you even get that shit? Wait, what? It's pi
Pi
times
r
d over.
square.
Oh,
Pi r
because it's
square.
already given
Given.
here.
Yeah, it's given.
And d is what? D is 0.36. And
Yeah. You
s is
divide
what?
that by two to get the
How do you
radius.
even get the s? S is what?
What is S?
It's 10 times negative 10 power of negative 3 over 2.
Bro, look.
Hmm.
Look. 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 What is the area of pi r square? Okay.
Pi
You
r
know the
square.
area is pi r square. Correct?
Pi r square. Yeah.
Yeah. So in order to get r, you need to divide the diameter by 2, correct?
Divided by 2. Why?
Because what is diameter? It's half of radius, right?
Yeah.
Correct. So that's why I have to divide it by 2.
So if I want to get the shit, it's basically A, and area is equal to what?
And then you have to convert the millimeter into meter. So you multiply it into the power minus 3.
Okay, it's just then just do this shit in the beginning. Okay, خلاص. Okay, so cross
It's easy,
sectional.
bro. It's easy. Basic
Yeah.
calculation. It's not even
Because
hard.
it's already told you. Yeah, it's already given.
Yeah, everything is given. Just put in the numbers and that's it.
Is equal
Yeah.
to pi d over s squared, which is equal to pi 0.36, because d is given, times 10 power of negative 3 over 2 squared.
Yeah.
This will give you what?
That's not S, by the way.
Huh?
You see the S? I think that's you made a mistake. That's not S. That's 2.
M over 2. Yeah, you're right. Okay, this is not s, this is what then?
D by 2.
D by 2, yeah? Okay.
Yeah.
D by 2, 0.36 times 10 power negative 3 over 2. Then over 2 is equal to 1.01 times 10 power of negative 7. Okay, and then cross-sectional area, I'll go back here, 11.9 times what? Times 1.01 times 10 power of negative 7. All of this guy is multiplied by what? Multiplied by L. L is what? 1.00. Okay.
Mm.
Not multiplied, over, yeah, over. Which is equal to what? Like this amount.
Mm.
1.205 ohms. Okay. And compare P, the given real value. Okay, so it will give me a value, yeah? Compare,
Yeah,
so
that's the
that
real
means is
value.
what is the error. So,
Correct. Correct.
so percentage error of, let's say,
Yes.
he gave me, what's the number? 1.22, yeah? Okay, so I'll just write my real
Mm.
one, which is what? L real. L real is what? 1.205 times 10 power of negative 7. Negative 6, I mean, negative 6
Yes. Correct.
minus 1 point, what's it called? Yeah, I think we made a mistake here also again. We're supposed to write here the. Wait, what? The real value. Wait, this was also wrong, yeah?
Yeah. You got
This,
lucky again.
no, this was supposed to be like, this is correct, the experiment, but the real is this.
Mm. Yeah. Correct.
Okay,
You made a
so,
mistake.
yeah. But I swear in the lab, my brain was like not working every week. Well, I was like, like this type of brain
Oh
rot.
my god.
I need. Uh,
Yeah.
well, I deserve to fail at this point.
No. No. No.
Okay,
You don't. You put in so much work. So that's good.
okay, error is this shit. We got our error. That's it. خلاص. That's the end of this lab. Okay.
Yeah.
So Eastern Bridge we just did power transfer. How many labs do I have so I don't waste of time? You have power transfer. You have Kirchhoff's rules. You have part one of this guy. I don't think this is coming. This is
That's
like
not
part
common.
two. And force on a current carrying and magnetic field. Okay. We have
Yeah.
five fucking more. Oh my god.
Okay. Let's do it.
This was what lab? Power transfer. I write it down?
Yeah.
I didn't think I wrote it down.
This is easy.
Power transfer. Calc 2. No, what's it called? Experiment 5. No, this is experiment 4, yeah? Yeah, okay, experiment. Okay. Power 69. There's no way he took 0.5. Well, this guy, I swear. He made me like lose 10% over like stupid stuff.
Thomas.
This guy, wallah, I swear, he's grading his ass. No way, well, the curve is gonna be bad at this point. But this lab has too many data. Wait. Power transfer.
Mm-hmm.
Isn't power transfer the one that I wrote so much in? Okay. Go to the video. This power
Yeah, I'm here.
transfer. Huh?
What happened?
From the source to the
Hello?
circuit.
No, I'm here.
Yeah.
Okay, so power transfer, resistance, we have internal resistance, colors thing.
Internal resistance. Yeah, let me explain. Just watch the video first and then I'll explain.
Diagram.
How many times am I gonna
Okay,
do
from
this?
the power supply to the resistor to the
Hmm?
amp meter
Which
in
resistor?
series. The
Tell
R.
We won't use this board.
What?
RS. So this is my RS here.
Okay, so I have this guy.
That board is called the DK. What?
Huh?
Yes.
Dick.
And then from the other side of RS,
It goes to the amp
No,
meter in
do you see
series.
the white color thing?
The dick.
The white color thing with like six dots,
The dick. The dick, bro.
six knobs. That's not the tick, bro. That's called the DK resistance box.
The dick.
The DK, bro, not the tick.
The dick, bro.
Oh my god. Don't write that in the exam, bro. Yeah, write that in the exam.
Wait, he
Cool.
didn't use any of it? Wait, that lab, you don't use
Huh?
this shit. I draw it for no reason. Wait, what lab do we use this shit?
Which one, bro?
Was it RC circuit? Oh, he didn't use
Which
it.
shit?
This one, this one.
Yeah, you know how to use that.
these
That's only for RC.
RC, you sure?
transferred again. Each time with
That's what
Yeah,
RC.
I did it, yeah.
three
This is
resistors.
Kirchhoff's law.
This part was when you have two capacitors.
Kirchhoff
This
is
is RC
Wheatstone
part
bridge.
1.
No, not the others. The bridge.
Okay, let's just do this
Yeah.
quickly before we
Transferred from the source to the load, and what value of RL should you have to get maximum power transfer, right? So again, set of equations, we derived few things, and all that is in the report. How's the connection now?
Oh, how am I gonna remember all this shit? Allah. I don't have like photographic memory.
During the exam, you'll remember.
Yeah, really.
You don't need photographic memory, bro. You just need like
Don't be a
not that
bitch.
hard. It's actually pretty
We have
easy.
some in here. Circuit diagram.
Okay, so let me just write the power
Hmm?
supply. We have minus,
Yeah.
circle, then positive. We have our ampere, we have our fine, and we have our V,
Mm.
volt. Okay,
Mm.
and we have
Okay,
our clamps, and we have two resistors there. This shit.
From the power supply to
So this is my
the
RS. It
Yeah.
goes to
This
the
is RS? Or what the hell do you call it? This is
Mhm.
RL ohms. Okay, the ohms are given, yeah? On this. Or volts or whatever.
Did you watch the video?
Yeah, I'm watching it. You're not seeing my screen?
Mm. I am watching.
From the other
Okay, we'll plug into the thing. We'll clamp it on what? On like boy, your voice is lagging a lot.
other
Finish
side
watching it?
Your voice is
of
lagging.
RS, it goes to the ammeter. Now this is the ammeter here.
Hello.
But did we use both? Yeah, we used both.
It goes
Is it still lagging?
Hello?
Hello.
Yeah, I hear
Hello.
back to the from the other
Yeah.
you. Yeah, I hear you.
From
Use
the
both for what?
we start from 20.
What are you saying?
No,
Hello.
nothing. It's okay. Don't worry about it.
Okay.
You good? You hear me? Hello?
Yeah, I can hear you now.
Okay.
Yeah, I can hear you now. Can you hear me?
Yes.
Okay. The fuck is wrong with my internet?
It's okay. Okay. So this guy has a clamp, and this clamp here is holding what? Is holding the charge, the resistivity. Okay.
No, the current will be low, so I
Okay, and then another
Hmm.
clamp will be clamped on the thing, and will be plugged to what? To the multimeter. First multimeter. 1, 2, 3, 4. This guy will be on what? On the second one. Okay, on the
can have it to the milliamp.
milli, and then from COM into RX.
From the COM to
RX.
the load, RL.
Or I mean, yeah.
Yeah, which is this one here.
Yeah.
The decayed box, this is the one which will be varying, RL.
okay, RL. We have two nodes here. Okay.
The load resistor, and then
Load multi hashtag 1 power supply.
from the other side of the
The power
RL,
supply.
Okay, so this guy, the negative one, the COM to
the
the
varying RL, the load resistor,
Mm-hmm.
and then from the other side of the
The power
RL,
supply.
it goes back to the power supply.
And then the voltmeter is in parallel.
this one to power supply. So this guy to the negative of the power supply.
Power supply.
And then the voltmeter is in parallel.
Okay. This guy will go to the negative one. Okay.
To what?
To the RL.
RL, which is this.
This.
Now you need to take care of the polarities. So
The black right now is the positive, so you put it.
the V here is connected to the. So
The black right now is the positive, so you put it.
the V here. Here is connected to the positive side,
Which
which,
is the
is
black.
this, and the COM is connected to the negative side, which is this. Also connected to your is connected to the
Okay, so this guy is connected to the
negative side, which is this.
this guy is connected here. This guy is connected there.
Also connected to your negative of the power supply. So this is your circuit diagram. Again, practice this. The circuit diagram will be given, but you should know how this is done. For the ammeter, you have the range here, so it could be 20 milliamp or 200 milliamp. And for the voltmeter here, you have 2 volts or 20 volts. Milliamp or 200 milliamp. And for the voltmeter here, you have 2 volts or 20 volts, depending on whatever you're getting. You are supposed to fix your power supply here now, so whatever the procedure tells you, set it to 3 volt or 7.5 or 6.5, whatever is mentioned. You fix your supply voltage and you find the power. How do you find the power? What was the equation?
So if I have my lab at 3:30, what time do I come to uni? Like 1 or 12:30?
Go at like 3 o'clock.
What do you mean go at 3 o'clock? It's at 3:30.
3 o'clock is not early. What do you mean?
Oh, the exam's at 3:30.
Okay, then go at like 2:30 ish, 2:45 like that.
Study at home? Can I not go to the uni and study in the lab?
Yeah,
I
study
can't.
at
I
home.
can't open the lab. They don't let
Study
you.
at home. Yeah, you can't do that.
Hmm? I'm gonna put an alarm like 12:30, 12:50.
You cannot go to the lab and use the lab.
Yeah.
The voltage
P
times
equal
V
IV.
current. V is equal to
Or I
VI.
squared or
VI. So voltage multiplied by the current. So the voltage drop you have on the load resistor and the current which is flowing in the circuit. Multiply them, this gives you the power. Now each time whenever you
Yeah.
change the load, you will notice the power is
Yeah, do
changing.
that.
You need to find the maximum power. So if I change RL, let's say I make it 40 ohms here, you have a corresponding voltage. Drop and the current 50, 60, let's corresponding voltage drop and the current 50, 60. So if I change RL, let's say I make it 40 ohms here, you have a corresponding voltage drop and the current 50, 60, let's say 160 and so on. So different values of RL is giving you the corresponding values of the voltage and the current.
so it's a table.
You tabulate this information, you plot the graph, and if you look at your lab reports, you will notice the power is increasing and then it starts to decrease. Where do you think you get the maximum power? Yeah, but at what value of RL? You remember? When do you think you will get the maximum power? What would be the value of RL? Same as RS, the internal resistance, right? This is the opposite side. Maximum value of RL. You remember? When do you think you will get the maximum power? What would be the value of RL? Same as RS, the internal resistance, right? This is
But from the opposite side.
Hmm?
But from the opposite side.
What do you mean opposite side?
So if it was 40 here, it would be 60 there.
No,
I think that's
40 40. They have to be equal each other.
RS should be equal to RL. You are lagging. You're very Stonebridge.
No, there was. Oh, okay.
Okay. Yeah. RS should be equal to RL for maximum power transfer. This was our theory, which we were trying to verify. And when you change all the values of RL, you get the corresponding powers. You plot your graph. The value of RL you will notice is equal to RS. Of course, you will verify this by getting the color codes and checking that value. Okay. Again, even if you don't recall that, it's fine. You still have 1 week to go back and look at your lab reports. Practice the connections now.
Okay. So let's do this. Hello?
Yeah, let's do it, bro. I'm waiting.
Okay, so I'm really sorry, bro, again.
No, it's fine. I'm just saying, like, I'm waiting.
Okay.
Let's do it.
So I just wrote the experiment how to do the steps. Okay, so it's like this is like the
Mm.
shortest one, I think. No, it's very long. I don't
Hmm?
think you will ask this shit here. Only like until here. What do you conclude between the relationship? I will just say
Mm.
this is like this looks like that, this looks like that. Well, this lab was just writing, I swear.
Yeah.
Look at this. No, I don't think I will get
Yeah.
but I think until here. I will just stop until question this guy. Okay. So let's do this quickly. Okay, so first one is what do we do? This is the circuit diagram. Okay.
First one, you connect all the circuits,
Yeah,
You do the circuit.
okay,
And
now
you
what
use
I
the voltmeter to get the volt.
okay, so it will give me like numbers, yeah? So let's say
And
from
then you,
20 until 50 basically.
yeah, they'll give you
This is on
they'll
the
give
thing, yeah.
you the RL.
Yeah, this is on
You
the
need to
load.
find the
This is
voltage
on
from
the
the
load, yeah.
voltmeter
On the
and
load,
the
this is gonna
current
be
from the ammeter.
this is on the load, so this will make this like first 20.
What?
On the RL will make this like 20, 30,
Yeah,
40, 50, yeah.
they'll give you that.
Okay, and the volts is what? Is
Yeah,
the
that's
calculated
given.
the power supply or on the voltmeter?
You have to find that from the voltmeter. From
Yeah,
the
okay,
voltmeter.
so the second multimeter.
Yes. And the ammeter you have to use for the current.
Okay, and the ammeter will give me the current. The
Yes. And then you have to
okay.
multiply I and V for power.
I and V, yeah, okay. So basically, ohms RL is what's told me to write, yeah. What they're telling me, and then I need to find the what's it called, the V, which is what? Which is the from the voltmeter VL, which is like I will get a number,
Yeah.
and then I need to find the I, which is the A ampere, basically a milliampere,
Yeah.
and then how do I get the third one? Is just what? It's just PL is equal to what? To L times V.
Just multiply V and I.
Yeah, I and V.
Yeah.
So let's say I got like the ohms was like the first one was 20, and then at 20
Mm.
my volts was like what 1.175, and the A was
Yeah.
what? The A was like 57.9. What I will
Yeah.
do, I will multiply 57 by 1.25, 1.75, and I will get like this, for example.
Yes.
So it will become
Correct.
what
Do that for
68,
everything.
0.0. Yeah. This guy multiply, then you get this. Then you do this 5 times, and then you
Mm.
get your data. Okay. Now we plot a graph
Yeah.
from this point
Okay.
to this point. It will say what? Plot the data from where?
Yeah.
Plot the graph amount of power. Oh, what the hell is this graph? I don't know how to do this shit. Okay.
Just plot a graph between
In
power
milliwatts versus the load
and
resistance.
milliwatt.
Okay,
Yeah.
milliwatts was what was the powers that we got, and the ohms
Yeah.
is like this
Yeah.
guy. Okay, so
Ohms is the
let's
RL.
say our minimum is like 68 and max 101. We'll start.
Yeah.
We'll make this is the our MW. So we'll make the minimum like what? Like let's say just
You know
68.
how to make the graph, right?
I mean this. It didn't say plot versus graph. It said plot the graph amount versus the load. Oh no, that's.
No. It's RL versus ohms. So RL is in the y-axis.
No, it said because it told you
Or
first. It said first the amount of parameter and milliwatts. Milliwatts is this guy.
oh, okay, okay. Yeah.
So it will
Then
tell
power
you
is in the y-axis.
yeah. Then ohms the ohms the RL.
Yeah.
RL is what in the next one, the
Ohms is
x-axis.
in the x-axis.
So we put our points
Yeah,
all of
yeah.
them and we put the points all of them. I don't
Mm.
know why he started at 0. I mean at 5 here. It's just to make them similar. Yeah? I guess. Yeah. Okay.
Yeah, yeah.
So he started what? First one is what? Is at this point and this point. At 65. What is it?
Mm.
At 20 here, and like
You know how to do all that, yeah? Forget it. Don't waste
20
time.
and 20 and like 67.5 I
Yeah,
think,
yeah.
yeah.
You
67.5.
can do all that.
No, it's
Leave
basically
all
this.
that.
See,
Leave all that.
68, 68.
Yes.
I'm not doing that. I'm just like
Yeah, yeah.
see.
This.
So we did the first point and then until the last point, which is like let's say 101.
Mm.
This is it, like here. And you just
Yeah.
make a line from the middle. RL max, yeah, I think he said RL
Yeah.
max is when RS is equal to RL. RS is what?
Yes,
Is
correct.
the color that we get the thing. You see? And how do we get it
Yes,
like from the
correct.
thing? The color code. Because he said if you want to know the RL max, it has to be the same as RS. How do you know
Correct.
that? By what? By the color, but our color showed us like it's 82. Huh?
Yeah.
Your voice is lagging, I can't hear you. Hello?
So your RL should be 82 then.
Your voice lagging. Okay, so RS has
You
to
got it?
be equal to RL.
Yeah.
Hmm. How did we even know to write 80 ohms without like doing this first? Huh?
No, that is the RL from the graph. Look, what is the maximum value? 80 ohms. Look, you got in the graph 80 ohms.
Yeah, but how did I know it was 80 before writing it? Oh, is it
What is the
because?
what is the what is the peak point?
Oh, okay, my bad. Okay, so RL
Mm.
has to be almost as equal to RS, isn't it? So the highest number that I
Yeah.
got was at this point here.
Yeah.
So we checked like from
Yeah.
here, it increases here until here, and then stops until here. So this one was like a
Correct.
okay. So our RL I mean is 80 ohms, and determine the value is what like
Mm.
get the gold. Gray is what 8, and the reduce so 82 times 1
Mm.
plus minus gold. So this is what you get.
Mm.
You forget to write the I think the
Yeah.
thing, yeah, units, which is ohms. Yeah, you have to just write ohms. M ohms or
Mm.
just
Yes. Yes.
okay.
Yeah. That's it.
Okay, and then determine the relation between RS and RL by by finding the derivative of the equation. I don't think this
No,
is
you don't have
difficult,
to do
yeah,
that.
because this look at this shit.
You don't have to do that.
Okay, and this is R experimental versus real. R
Yeah, you know how to do
is
that.
what, I mean, no, we also made a mistake here. It's supposed to be R experimental minus real over real times 100. Yeah,
Yeah.
and the real is what? Is the 82. 82 which we got
Mm-hmm.
from the resistance minus 80 our peak over
Mm-hmm.
82 divided by 100 times 100 is equal to
Yeah.
2.45%. And then what we can just talk, just keep it. It's under 5%. It's like that and like this and like that. Okay.
Yeah. Yeah. Yeah.
Culture's roots. I wrote this down so you don't need to watch the video. Yeah, okay, so this should be it.
Mm.
Okay, so this is our diagram, part 1. Okay, part 2. Part 2 is not coming, yeah? Or no, only part
Two is not coming. Part two is not coming.
for no, for Kirchhoff's law. I think part 2 is
Yeah,
also
it's not
coming.
coming. It's not coming.
You sure?
Yeah, I asked
Ask 2. Balaji.
Balaji.
Okay, so we first the Kirchhoff's law. We have like this box here, this rectangle.
Yeah.
It's like what it has like 9 ports. Yeah, 1, 2, and the
Mm.
middle 4, 5, the 6, 7, 8, 9. And this is like what we studied again to R1 and R2. The conjunction is this guy, and then when it's going down,
Mm.
what's the one n? The n is I1 and I2, and what's the out? I3. We have VSI and we have R3 and VS2. This is the loop. This is our group here. And this is
Mm.
the loop here. Okay.
Yeah.
Okay. So how do we get each number and everything? Okay, for first R1 VSI. How do we get VSI first? Right after we write the power supply. So first we put all the numbers. Yeah. First power
Mm.
supply, the positive will go to the 1, and negative will go to the second multimeter. Yeah, we didn't. We only used one multimeter. Yeah. Or we also used 2.
No.
We only used 1.
You
Yeah.
need, you need one and you have to use that to calculate all of them.
Yeah, only 1. Yeah.
Yeah.
Okay, so if I can draw it for you, let me just open paint so you can just explain to me. Okay, so this guy, we have a box here. Where is it? Box here.
Mm.
This guy, and we have like this boy, this bad boy here. Okay. And you see here, this is what? This is our negative. Something in the middle, I don't even know what it is. This is our ampere, this is our fine, and this is our volts. This is the power supply. And this
Mm.
is what? This is the box load for what? For power, for Kirchhoff's law. Which is like what?
Mm.
Call this 1, call this 2, call this 3, call this 4, call this 5, call this 6, call this 7, call this 8, call this 9, yeah? So
Mm.
this is, let's just say, yeah, what? So you know this, yeah? Just say
Mm.
1, 2, 3, 4, 5, 6, 7, 8, 9, yeah?
Okay.
And then this is what? This is our multimeter, 0, 0, 0, 0, circle. Okay, so this will become what we'll use the volt one, yeah. So this is our, I will call this amp 1, and this is amp 2, this is com, and this is the
Mm.
voltage, yeah, like this.
Yes.
Okay, so first is what we take a wire. I wrote this down, so I'll just check it. Okay, so first at V1 is this guy here, this one here at V1,
Yeah.
and then yeah, and then V2, what's it called? Yeah, this guy and this guy here,
Mm.
this guy and this guy here,
Yeah.
and then this guy and this guy. So just like yeah, put this guy here, and this guy and this guy here at
Yes.
first. And yeah, by the way, I made a mistake. I think before I draw them, this guy is supposed to be like this. Wait, let me just cancel the guy. It's Control V. Oh, it's weird. Okay. Nope. Eraser. I guess eraser. Delete this guy. Okay. So I should have done this. My bad.
What
You
happened?
see this? The power supply. It's like a different type of power supply. It's not the normal one. We have what? We have like 2 volts here and 2 volts here. And then this is minus, 0 positive,
Hmm.
This is our power supply. Power. Is it 2 or is it 6 loops? We can just check quickly. This is the cartridge loop, yeah? It's, yeah, 4. Okay. So, going back to the thing, okay. So, first we take two wires, yeah? We plug the
Hmm.
let's call this the R2. Okay. So, this guy and this guy together. Call it this.
Yeah.
Okay. This guy and this guy together, and this guy and this guy together. And then, what's it called, the second one? Uh,
Connect the 5 to the 6.
3. Wait, this is supposed to be called 3, my bad. This is 4, this is 5. Yeah, okay.
Connect the
So
3 to
2
the
to
6.
3 and 4 to 3, and then 5
Connect the
to
3 to the 6.
2 to the 6. Not 2 to the 6, you mean another wire to here.
Yes.
Yeah, and then
Yeah.
what's it called? Yeah, one to negative, and then another one to what? To this guy here, to the
Hmm.
negative. R1.
Yes.
Yeah, here, and then this guy to this guy, and this guy to this guy, and 9 to what? 9 to negative.
No.
No, 9 to positive. I mean, yeah, 9 to
No.
positive.
Yeah.
Yeah, yeah, 9 to
No.
positive.
No. Negative. Negative.
Yeah, it's a negative one.
Yeah.
5 to
Yes.
yeah, 5 to positive. My bad.
Yeah.
Okay, so 5 to positive. This guy with, yeah, 5 to positive and 9 to negative,
Hmm.
and that's it for now. Then we go to the multimeter. We go to the what, to the what's it called? Yeah, one will come with what, with V,
Hmm.
and the com will become with what, with 7. Yeah.
No. No. Yeah. Yeah. Correct. Correct.
Okay. How can you even imagine? I'm drawing this so badly, and you can still.
Yeah.
Okay. So okay, now we're here, yeah. Now
Yeah.
how do I find what? For example, how do I find my first one, which is like, let's say VS1. VS1 is what? Is plug the V2 to 1. So where is V2? V2 is this here. So V2 will take this to what? Uh, V2 MT4 to 1. Yeah, I'll plug this guy to 1. Already done. Then plug
Hmm.
COM to 7. Yeah, here, done.
Hmm.
This is how we got our
Correct.
VSI. Okay, so this is, let's say we got this thing, like it will be 8.1. Then how do you get the second one? V1, which is like what? Let me open the thing.
Remove the wires. No. No.
Uh,
Why? Why? You know it by yourself. Don't look.
no, I want to be similar, ولا? Okay, خلاص, no problem. Just do it by
Hmm.
yourself. Yeah. Okay, so V1 is what? I'm
First remove
looking at
the
my notebook.
first.
Is this considered
First
cheating here?
remove the wire. First remove the wire. So go back.
Yeah, no, here. Now at V1 is what? Is move, what's it called? V2? I mean, not V1, yeah.
That's why I said to stop complicating things. Remove the wire from the V1. VS1. I mean.
Yeah, I know, we removed it.
No, you didn't remove it. It's still there. Look.
Don't look at it here. Now just imagine now.
Okay.
Okay, I'll use the purple color so you can understand it.
Just erase it, bro. What do you mean?
Okay. So we plug V2 to 1. You see where V2 is?
Hmm.
From 1 to 1 again. Then plug COM to 2. So you see this guy? We don't change this guy. We take this guy now to what? To here. Like it was what?
Hmm.
The com was from 7
Yeah.
and it went to 2 now.
Yeah. Correct.
Yeah, okay, so we got like what? To become like 445.1, like for example. And then
Hmm.
V2, you have to write ohms, yeah? Or what?
No, it's a volt.
Okay, just write okay. And V2 is equal to what? V2 is equal to, yeah. Okay, so V3, I mean, you
Now
got
you just now you
V3.
complicated everything because you put like a lot of wires from the same thing. That's why I said erase it.
Oh, I mean, how do you need to raise this shit?
Only the wires over there. Or just press the reverse button.
If I delete this.
Hmm. Remove the red wire coming from the voltmeter. Two red wires. Yeah, like that. And the other one also. Yeah, good.
Okay, so as we said, first VSI to other, this guy will just basically take the com to 2.
Yeah,
Yeah, and for V1, yeah, I mean,
yeah, yeah.
VSI is just the same with the red, the V2, with the com at 7 and V2 at like 1. But now
Yeah.
for the V1 is just what take the com to what? To 2. And now for V2 is what? Take the, what's it called? Take the V2 to 4. You see what
Hmm.
V2 is to 1, we'll take it to 4. And the thing, and the com
Hmm.
to what? The com will go to 3, to this guy here.
Hmm.
Hmm. Then we get what? We'll get like, let's say how much? This is V2, V3,
No,
V3.
no. Com will go to 4.
Com will go to, yeah, here. No, here, I mean, yeah. My bad.
Yeah.
V2 will go to,
5.
V2 will go to 5.
Yes.
Okay, so V2 here. And com will go here to V4.
Hmm. Yeah.
I don't know why I wrote it like that.
Hmm.
Wait, com will go to 4, you mean? Wait, com will go to 5, you mean?
No, 4.
4, okay, com will go to 4 and volt will go to 5, yeah.
Yes.
Okay, so V1 was like what? Like 45.1, and this guy was like 3.10, and this guy we got what? 3.51. No, no, yeah, okay. So at V3 is what now? V3 is plug V2 to 6. So V2 is this guy, we'll plug it to 6, to the one under 3. Here. So when we
Yeah,
plug this
6.
guy, yeah, when we plug this guy here, it will become what? Like
Yes.
this, and we plug com to 8. This com here to 3.
Correct.
Okay, so it
Good
will
job.
become what? This guy, V3, it will become 3.51, like V. Okay, and then like next to it, we'll just write Vs to I. No? Vs to I is equal to what? Is equal to plugging V2 to
Yeah.
5, yeah. So this V2 will still go to 5 now, and the com
Yeah.
will go to 9 now, here.
Yeah.
Okay, so then we got what? We got like a number. From the look at the power supply or the voltmeter here to get the number.
Voltmeter.
Yeah, so the number will be here. Okay. Now for I1 is just basically what? We'll just switch this guy to. We'll take V2. We'll just make another box quickly. This guy here. So
Remove delete that guy.
yeah, we'll just write this guy here. This guy. Okay.
Put an A. Put an A.
And then
Yeah, you can write an A over there.
yeah, this is like ampere. Yeah. Amp, and this is voltage.
Remove the volt. Now it's done. You
No,
don't need it anymore.
I know, I'm just saying this. Now for the I1, yeah? This is the first
Remove the
and
wire
second
coming out
equation.
from the volt at least.
No, we'll just do another one here next. Okay. Yeah, and we don't touch the power supply, I think, yeah? Like
What does that mean?
after this point, we don't touch the power supply. We just continue with the voltage to the power. Here,
Yeah,
just
yeah.
the I. Yeah, okay. So just the same shit, yeah. So this guy will do another box next to it. Yeah. Okay. This is like the points again. Just write them here. 2, 3, 4, 5, 6. This is 6, 7, 8, and 9. Okay. Okay. So first ampere, we have ampere 1, 2, com and volt. We'll leave the thing, we'll leave what? We'll take V2 from here, we'll take this, we'll put it to M1. So we'll have 1 here, yeah? And we'll take this guy to what? M2, yeah? V2 to M2 here, first. Then break off 2, you see what number 2, we'll remove it and put it to MT, like, and plug it at 2. You see this guy, we'll plug it at here, yeah? After we remove,
Mhm.
yeah? We remove it from
Yeah.
here. Okay, so we'll get your I1, we'll get it.
And then
And
put the
then what?
negative.
And then plug the com, this guy, to what? To the conjunction here.
Yes, correct.
Okay, so I2 will be what? I2 will return this guy to how it was.
Yeah.
We'll return it to how it was basically, and then what? And then yeah, we just redraw the guy. Okay, and then I2 will become what? I1 is just wait. I will just write different colors. So this guy is what? We took it to I2, and then this comb to what? To conjunction 3. Yeah.
Yes.
Oh, please be patient with me. Don't give
It's
up on
fine.
me.
It's fine.
Don't give up on me.
I have a lot
Okay.
of patience.
Okay.
Actually, no, I don't. That's
Huh?
my one problem. What?
Okay. So
My,
now
my
we
mom
fix.
keeps saying I don't have patience.
Bro, you have so much. Bro. If you can handle me, bro, you can stay with me for more than 1 hour. You have way too much.
It's good. It's good. Come on, do it.
Okay, I2 now is what? I2 is going to be taking the, what's it called? The
Mm.
voltmeter from, well, first we'll fix 2, we'll fix it to how it was originally, then we'll break up 4, we'll remove 4 and we'll plug the thing here and com will stay here.
Good. Good.
Com
Very
will
good.
stay here. So this guy will become what? This guy will go here, and then com will
Yes.
become again what? Again here, 3. Okay,
Correct. Very
we
good.
finished it. Now I3 is what? I3 is just
Can you
basically,
remove all this? Can you remove all this?
sure.
Yeah. Okay.
Okay,
Yeah.
now
Okay. Now done.
I3 is what? I3 is this guy. We move what to what? I'm losing my. Okay. Yeah. So we'll break off number 6. You see number 6 here? We'll remove anything on it. Break it off. From
Okay.
what? And M2 to 3 to the conjunction. So this guy here to the conjunction, and then
Is that the
this.
positive?
It's the positive. Yeah.
Okay. Yeah.
Then
Correct.
this guy come to what? Come to number 6.
Correct.
So
Very
this
good.
guy will come here. But this after what? After breaking 6 off.
Yeah.
Okay, then after that I get all my numbers and I finish the thing.
Yeah.
And
That's it.
now, how did we get each thing here? I want to know like what solvation. Okay, so I1, I2, I3, I got it like by doing the thing. I in and
Yeah.
out, we know how it is. It's just I1 and I2 together. I in
Yeah.
will give us milliamps, and then I out is just
They'll give you the
milliamps.
formulas, I think, and you can just substitute that.
And the difference is what is in and out. Yeah, if it asked for the difference, for example, what's the difference? Blah blah blah. This guy,
But
the in and out
അമ്മാട്ടെ
are
മറ്റൻ
matching.
കേട്ടാ சொல்லு
Huh?
അമ്മാട്ടെ മറ്റൻ കേട്ടാ சொல்லு
Okay, so okay. God damn, my legs. Hello. Okay,
yeah,
so
go on
the difference is what is just in inside minus outside over inside plus
mm.
outside over 2 the times 100, then we'll get our number, then we just talk about the thing, blah blah
Mm.
blah, and then checking the Kirchhoff's law, we wrote all the numbers. You know how we just found it?
Yeah.
This guy, how did you say we found VSI? We
Yeah.
we plugged the number, the V2 to what? To 1,
Mm.
and plugged
Yeah.
the com to 7. And then
Mm.
V1, VS2, how did you get VS2? VS2 is plugging V2 from.
You do that, don't say it again, my mind
I
will
want to
break.
know, I want to remember for
Mm.
myself. It's okay, you
Okay,
don't need to remember,
okay.
you already passed.
You say
Plug, okay, so plug
okay.
COM to com to 9.
Mm.
Okay,
Yeah.
V1 is what? Just plugging V2 to 1 and com
Mm.
to 2. And V2 is what? Plugging V2, the guy there from the voltage, from the second one, to the number 5, the one on top. And then V3 is what? Plugging the V2 from 5 to 6 and the com to 8, the one under 6. The one that we said, this one. You see this guy? This is 8.
Mm.
You see, saw the drum? Yeah. And P4, I don't think we needed P4. Okay, and then loop 1, loop 2, loop 3. Yeah, okay, so this one is just writing. We already have each number here.
Mm.
So VS1 minus V1 minus V3. Yeah, because VS1 we got what at VS1? Remember what he told me? VS1 has what? It has like minus. It has the resistance 1 and the resistance 3, yeah, which is I1 and I3, yeah. But remember
Yeah.
what you said? You said the charge like becomes negative electron, like constitutive, then
Mm.
it's opposite. Yeah?
Good, you remember. Good job.
Yeah? So this guy, we just add them. This will be our first loop. Will give us what?
Mm.
0.06. We just add all the numbers that
Mm.
we already got. And then loop 2 is
Mm.
just what? Loop 2 is just from the opposite, the other side. This one. So it's
Yeah.
like what? It will become positive actually. Yeah?
Yeah.
No, it's actually negative.
Correct. Correct.
Maybe we made a mistake. Okay. So Vs2I, it will become like this. Or maybe opposite
Yeah.
the same way, I don't know. Okay. So Vs2 minus I2 over minus I3, yeah? Yeah. Minus V3, V2, V3, yeah. This is good. Don't think this shit is coming. You said part 2 is not coming, only part 1. Okay. Discuss your results. Then after we get our answers, we'll just do that. And loop 3 is just what? What is loop 3? It's just Vs1 minus V1 plus V2 over Vs
Mm.
minus V2. How is there a third loop? It's just basically what? Like from this guy until here.
Mm.
So R1, R Vs1 minus V1 plus V2. Oh, it's like this is the first loop, bro. This is the first loop, yeah. And this is the second
Mm.
loop, yeah. And this is the third loop,
Yeah.
like the whole thing.
Mm. Yeah. Correct.
That's why we didn't write V3 in it. So minus Vs1 plus plus V1, then minus not minus V1 plus plus V2 plus Vs2, not minus Vs2, minus minus plus minus. Okay, let's go to the other lab.
Yeah, bro. I'll just go eat and come. Yeah. My mom is calling me for dinner.
Then I will go eat also.
Yeah. Okay. Go eat. You wanna call later? What time you wanna come back?
I have just these. How many are left? RC circuit.
Yeah.
Or just give me a second. I just want to look at it quickly. Yeah, this guy. Yeah.
Oh, where am I? 1 second. I'm coming. Yeah. Yeah.
Okay, okay.
We'll come and do this.
We'll just do these last three and then خلاص. We'll take like
Yeah.
max
Okay.
I think 40 minutes, 30
What?
minutes.
Yeah.
Okay, take your
All right.
time and
Fine.
tell me when you come. Huh? I will
Yeah.
be
Just
back
call
in
me
like
once you're done,
I will
or
be
I'll
back
call
in
you
like
when you're
20 or
done.
30 minutes. Yeah.
Yeah. All right. Fine. See you. Bye.
Hey, bro. You just disappeared, dog. I got scared. I have nothing. I have nobody to contact you. Hello?
Yeah, hello?
Yeah, can you hear me?
Yeah, hello.
Yeah, yeah.
Hello.
You're on your computer?
Yeah, yeah, I'm on my laptop.
Bro, I was like, shit. How do I contact him? You have like, I was gonna email you, bro.
No, no, no. Yeah, I was just cooking some food. Yeah, go on.
Yeah, your phone died.
Yeah, I know. I was in the kitchen and then I forgot to charge my phone.
Yeah,
Yeah.
okay, so we have just 3 more labs, and
Yeah.
think they are not like that long. Let me just.
It's not long?
I don't think they're that long. The last.
Okay, let's start there. Start doing it.
Let me just open this physics. Yeah, let's do it quickly. So first one is RC circuit.
Yeah.
Let me just share screen. This is the RC circuit. I think this is it.
3 resistors. In the second part, we have 1 power supply and 4 resistors. So for the first part, let's do our connections. First step is to have our circuit diagram.
This is not RC, is it? No.
What?
This is RC, I think.
This part was when you have 2 capacitors.
Okay, RC. Experiment 7. No. Experiment 6. Experiment 7. 9. Experiment 10. Experiment 7. This is RC circuit part 1 only.
Yeah.
One
Start
time
doing
you're connecting them in series, the other time you're connecting in parallel, so you don't have to worry about this. The only part you have to worry about is the one where you're using the stopwatch.
Okay, we only need 3 things, yeah, the timer, multimeter, this book, and
Yeah.
what else? And the power supply, yeah?
This will give you the
Yeah.
Okay, so let me just download this quickly. The books. This guy, it's 12 dots, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
discharging. Actually, that was the easy part. Let's do the connections. How were the connections? So from the positive of the, let's do the connections. How were basically charging and discharging is the one where you're using the stopwatch, where the capacitor is basically charging and discharging. Actually, that was the easy part. Let's do the connection. How were the connections? So from the positive of the power supply, it is connected here, which goes through the resistor, and then you have a capacitor. It's connected here. How were the connections? So from the positive of the power supply, it is connected here, which goes through the resistor, and then you have a capacitor, and then from this end it goes back to the negative of the power supply. That's it.
Okay, so 1 and 6.
Which goes through
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay.
the resistor, and then you have a
And bro, for the part 1, you only
Capacitor.
need this, yeah? The 6.
Yeah.
Okay. Okay, so 1 is it this guy?
the capacitor is basically charging, and from the positive of the power supply, it is connected here, which goes through the resistor, and then you have a capacitor, and then from this end it goes back to the negative of the. That's it. You know, you just have a power supply, you have an R, you have a C here, and that's it. Of course, there are these extra connections here to have your voltmeter, because you want to note down the voltage across the capacitor when it is being charged. So the positive is connected there, and the COM is connected to this side of your is connected to this connected there, and the COM is connected to this side of your capacitor. You have the positive terminal and the negative. You would need a shorting wires initially just to
watching the video?
capacitor. So now
Don't you see my screen?
if I switch on
Yeah,
the power
okay.
supply, again the procedure will tell you set the capacitor. So now if I switch on the power supply, again the procedure will tell you set the power supply to inverter. If I switch on the power supply, again the procedure will
These two are connected, yeah? So you can like do the discharging or charging. Huh?
What?
These two are connected, yeah? Together.
Yes. Yeah.
Okay.
tell you set the power supply to a particular value. Let's say in the procedure you had 8, so you will set it to 8 here. What would be the voltage across the capacitor now? Is it charging? Do you think it's charging? No. Is it charging? Procedure you had 8, so you will set it supply to a particular value. Let's say in the, again the procedure will tell you set the power supply to a particular value. Let's say in the procedure you had 8, so you will set it to 8 here. What would be the voltage across the capacitor now? Is it charging? Do you think it's charging? No, right? Because it is being shorted now, so it's not charging. I need to record the voltage across the capacitor and note down the time. So when the time, what was the time when the voltage across the capacitor was 1 volt, 2 volt, 3 volt? Because we studied that it's charging exponentially. We looked at this relationship. You need to plot that relationship, right? So you need to get the time and the voltage. So I have to switch on the stopwatch, be ready with it, and record the time whenever the voltage across the capacitor has reached about value, right? So 1 volt, 2, 3, 4, 5, 6, let's say till 7 for charging. And then I'll repeat that for discharging, right? So just
Bro, for charging, you just do it until like let's say they give us the procedure 8, yeah?
Yeah.
And as soon as I pull the plug on the number 5, which is this one, I start the timer. This is for charging, yeah?
Yeah. Sure.
Like after like every until every volt, this is what I count, yeah? The event for each time.
Yeah, you have to keep stopping the event at each turn.
Yeah. And what if it's about the discharge? Same thing?
Which
or-
one? Discharging is when you charge it till 8 and then you let it like slowly go from 8 to 6 to 7 to 5 to 4 to
Oh,
3
so
to
it
2 to 1.
became so as soon as it becomes 8, I put it
Yeah.
back until
No, it
it-
depends on whatever they tell you to do.
Yeah, no, not 8. I mean, like, okay. Let's just finish the video and I'll explain what I mean.
Like say for example they tell 6, then you do 6. If they say 8, then you do 8.
Yeah, until it reaches like each
Yeah.
volt, like by 2,
Correct.
4, 5. Okay, just see it.
Yeah.
and start. You notice it is charging.
Okay, this is for charging, yeah. For
This
charging.
is the charging, yeah, I think.
Yeah, then remove plug 5. Yeah, remove plug 5.
What is lap time?
This one. 1, 2, 3, 4, 5.
Uh,
Start timer. Start timer. Plug 5.
So here, and when it reaches 1 volt, just
Okay, so every time it reaches a volt, I count like from 1, then 2, then 3, then 4, like that, yeah?
yeah.
Then press event after every 1 volt, yeah?
Yeah.
After every 1 volt to what? 1 volt until what? Until 8, yeah? That's the maximum is 8, yeah?
Yeah.
Cannot go more because that's what we set the power supply to.
Maximum is, it depends on whatever they give you.
Okay, yeah, I know. I'm just saying, what about the?
save that event so you can record it.
What about this case? I think it's 6.
For 1 volt, and then 2, and then 3, and then 4, and so on. Plot that relationship. From there, you can get the time constant. So in this
Plot
experiment,
that relationship, and then you can get. Okay, then plot
What?
relationship and get time constant. And get. Constant.
you're basically trying to determine the time constant for this RC circuit. How do you get the time constant when the capacitor is charging?
0.6.
63% of the supply voltage, right? So get the
0.6.
63% of the supply voltage, right? So get the 63% 3%
Bro, do
of
you
its
know
value.
anywhere in UAE where you can get like, especially Dubai,
Mm.
where you can get raw milk?
Raw milk, like what?
Yeah. Huh?
Like cornflakes milk, like you're gonna eat
No,
cereal.
no, no, like raw milk, like directly from the cow.
You mean the cow?
Yeah,
I need to go farms.
yeah, but like, do you know any farms in Dubai or some shit?
I'm not sure. Rahmani in charge. There's a lot.
Because you live in UAE, you're like a national like person, yeah. Like,
Yeah, yeah. I'm actually, but I'm
you're
not
like an
sure.
Emirati, so like, do you know any bits?
I'm not sure. Oh, I want to
You
try
know?
it. It's actually good,
Huh?
you know. It's good.
What?
It's rich. It's rich. It's good.
Yeah, yeah,
I
no,
tried
that's
it
right.
once, but I don't remember where.
So like, I wanted to know if like you know any farms or shit.
Don't. Too expensive.
Yeah. I don't
Yeah.
know.
We'll give you the time constant from that curve. For
Yeah.
discharging, what did we do? We first completely charged the capacitor to whatever value is asked, and from there we discharge it.
Okay, bro. If it, I remember they said for RC circuit, there is two
Yeah.
cases. You'll either get charging or discharging, not both. Yeah.
Yeah, correct.
Yeah.
It's either one.
So if you get like if I get discharging, I will just wait
Yeah.
for it until it charges fully. Then
Yeah, yeah, correct.
then as soon as I plug it, I'll start the timer like from going from 8 to 7 to 6. What they say the procedure they said 8. I will wait until like it's fully charged.
Yes,
Same
yes,
shit
correct.
until it's like 7, 6, 5, 4, 3, 2, 1, like that.
Yes, correct. Correct.
Across the
Correct.
resistance. Right?
Then same for what? For constant, not for constant, for discharge. But wait until it's fully charged. Wait until full charge. So what? Then plug 5 back. Then time watch. Yeah, time watch to what's it called? To 0 no. Time watch to event. To each event from 8 until 1 ohms, yeah? Not until 0, or we count
No,
until
2-0, 2-0.
from 8 to 0. From 0 to 8. 0 to 8. Okay. Now I understood this. Now let's go to the lab itself here. Look at my screen.
Yeah.
Okay. Can you see it? Okay, see the first part. It's just I think you just do these guys. Okay. So first question is what? Is read supply voltage E0 using digital multimeter? Okay. And they gave me 8, yeah? So I will start like at 8.
Yeah, yeah,
Take the
correct.
time reading from like 0 to 1, 2, 3, 4 until like 7. Until 7?
Yeah.
Set 8.
No, it depends on whichever value they give you on the paper.
Okay,
Like, for example,
let's say they give me 8.
yeah, then it,
Hmm? But then why
they
did it
give
say
you
up to
and don't
7?
really.
Or it does not matter, yeah?
It matters,
Oh,
it matters.
because 0 to 7 is like 8. Like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for charging, I will write this guy and this guy, and for discharging this guy and this guy.
Yeah.
Time charging is what is equal to VC, which is volts, and this guy is seconds.
Yeah.
Okay, so first one like 0.00 and 0.00, and then like 1 second, and then boom, 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 boom to 7.00.
Yeah.
And like this guy became what? 14.48 seconds to 230.5 0.08 seconds. Okay, and discharging is just same thing, but opposite.
Yeah.
Discharging of a capacitor. Okay, so this guy and this guy time shift. This one will be from 8.00 and 0.00. This is seconds, and this is VC equal to V time. Huh? I don't hear you, bro.
I'm not talking to you, my brother.
Okay. Okay, bro. How do I do this now? With these, you see these?
Plot the graph. Plot the graph.
Okay, so this is the graph. What it looked like. We made it like this, I think.
Yeah.
So we put what versus what? VC versus time, and the same thing for here. Okay, it does not need to be like this because this is like it's like it will be either one of them. Let's say I got charging, yeah.
Mhm.
Okay, so I will be like VC minus what minus T. So I will start the V to 0, like from here,
Yeah.
and I will
Yeah.
start the time also 0. Okay, so I'll put my max time, which is like 7, and then I will add like 8.5 seconds like this.
Yeah.
And then for the what's it called for the seconds? No, not time. This is the VC first. Yeah, this is VC. Yeah. Hello. You here?
Yeah.
Okay. So you understand what I'm saying? Okay. So we'll
Yeah.
just like plot a graph.
Mhm.
Plot a graph. Either if it says like discharging or charging, it does not matter. I'll just make the y-axis like first this guy, and then the x-axis like
Yeah.
this or charge, any one of them.
Yeah.
It will become what? It will become VC minus VC versus time.
Mhm.
Time second. This is volts and this is times. Yeah. Okay, so I will put like the minimum number 0.0 and the highest time is like 8.5, and then I will put like the highest the lowest volt 0.0, and like the highest, let's say the highest is 230. Yeah? I will put like 245 just for the reference.
Yes, correct.
245.0. Yeah.
Yeah.
I'll make it like this guy and like this guy, and I will like start putting all my stuff or what exactly, like all my points. Yeah. So at 1.0 is like this
Yeah.
guy,
Yeah.
and then this guy, and then this guy like this. Like say, let's say we're doing charging. Yeah.
Yeah.
Like this, and then discharging will be like opposite, like from 8 and like that. Charging
Yes.
and
Correct.
this charging. Okay. And then this is I will use y2 minus y1 or no need for this.
Y2 minus Y1. Yes. No, not for
Yeah.
this. For this, you don't.
Yeah, for this charger. But how do I know
Yeah.
the time constant? See, we found it here.
Time constant. You should multiply R into C.
Time constant, which is constant,
Yeah.
is
You have to
equal to
multiply the
what?
resistor into capacitor.
Multiply what by what?
The resistor into the capacitor.
Resistor times capacitor.
Yes.
What is the resistor here? How do I know?
R is the resistor.
Do you have to look at the colors at the?
Yeah.
you
Yeah.
know,
Correct.
Huh?
Color.
How many colors are there? Because like when you see here, there's a lot. There's like 1, 2, 3, 4, 5, 6,
No.
7.
No. No. You know the color of the resistor?
No, which one is it? This one or this one or this one?
The one. The one.
Oh, this one, the middle.
The top two. The top two.
This one and 2.
Yeah. That one.
These are the resistor.
Yeah. And the below one is a capacitor.
So this is the resistor and this is the capacitor.
No. 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 The one on the side.
This is 1, 2, 3, 4, 5, 6. Say the numbers.
1, 2. Which was 5, 6?
This 5 and this is 6.
What is the one above the 5?
2.
Yeah, that one. 5 and 2 is a capacitor.
5 and 2 is the capacitor. So
Yeah.
I look at the color that's like here.
Yeah.
And then
No, no. The value of the capacitance will be written on it.
it will be written on it. Like I can see a
Yeah.
number there.
Yeah, it will be 1000 microfarad.
Okay, then what about the capacitor? I mean the capacitor.
Yeah, capacitor will be written. Resistance you have to find out using the color code.
Okay, so the capacitor I will get like let's say I'm writing in my notebook here. I'm saying resistor times capacitor. So resistor,
Yeah.
let's just say the resistor we got like 82. Yeah.
Okay.
Remember like the last time we got like 82 and then the resistor calculator. Let's say we got this. Okay. You see this?
I got 91.
Huh?
I'll see what it is actually.
Can you see my screen?
Yeah, I'm seeing.
Take your time.
No, I'm seeing.
Your voice is far. Where are you?
I told you I'm in the kitchen.
Oh, you're in the kitchen.
Yeah.
You're still cooking.
Yeah.
Where are you cooking?
You wanna see?
Sure, show me.
Yeah. I'm not cooking. I just took it out. Wait, can you see my camera?
No, it's not on.
Wait, use camera. No. Yeah. Can you see?
Show me.
Yeah.
Oh, nice.
Smart it.
Good. It's amazing cooking.
I mean, I'm not that good, bro. My mom is so much better, but like, yeah, my mom is sick, so I have to make it by myself.
That's really good, bro. Amazing.
Yeah. But fine, come on, let's see.
Yeah, okay. Okay, let me continue. Okay, so as you said, this one.
Mhm.
Yeah, so you said this is the capacitor, yeah? It's given. It's like you said microfaraday?
Yeah.
Huh?
Microfarad, 1000 microfarad. You have to convert it into farad.
Okay, so this will become what? Micro
Just
Faraday.
multiply into 10 to the power minus 6.
And this is what the capacitor is actually at number 2 and 5, yeah?
Yeah.
2,
Just multiply it into 10 to the power minus 6.
6. So yeah. So this is the capacitor, yeah? This is the microfaraday. We have to turn this into what? Turn this
Faraday.
into Faraday.
Mm.
Okay, so if you want to turn a microfaraday into a Faraday, what do you do?
Multiply into 10 to the power minus 6.
10 to the power of minus 6.
Yeah.
So this is 10 to the power of minus 6. And the micro is 10 to the power negative 3.
No. Micro is 10 to the power minus 6.
And then without Faraday itself is what?
What?
If you said microfaraday is 10 to the power of negative 6, yeah?
Yeah.
What about to turn it only to Faraday?
No, you turn it into farad is 10 to the power minus 6.
And to turn it into microfaraday?
From microfaraday, if you want to turn it into Faraday, then you
Yeah.
should multiply by 10 to the power minus 6.
Okay, so multiply by 10 power of minus 6, okay. And okay, and the resistor is what? Is what I should get, yeah? Like you see
Eventually, you
this?
can get the current code, eh?
Yeah, like from here. Like for example.
Yeah. Yeah, come on.
Okay, so like first number is like 5, and then 2. And then what is M? M is what? Stands for what? Micro ohms.
Yeah, where is L?
Huh?
Where M? Yeah, M is milli ohms, I think.
We're 4 bands, yeah, not 5.
Yeah.
Okay.
No, we're 4, we're 4. What are you doing, BMI?
This is the same website. Okay, so okay, let's say I got 52, yeah. So how do I
Yeah.
calculate? So I write my resistor as what? 52, and my 52 micro ohms, or what exactly?
What's here again?
You see here,
Yeah.
this is how we got the time, yeah.
Yeah.
Time. What's it called? Constant or change
Yeah.
or time charging and time discharging.
Okay.
Yeah. Determine the time constant. Work on the graph.
Yeah. I told you, yeah. Just draw a graph and then mention the time constant value over there.
Okay, yeah, but how? How do I get the time constant? As you said the
I
time
told you
constant is
multiply
what?
R into C.
As resistor times capacitor?
Yes.
Okay, so let's say I got my capacitor as this. How do I put it in the calculator? This one first. 52, yeah? So
What?
I write on the calculator 52
Yeah.
and then times what? The resistor, yeah? I mean the capacitor.
Yeah.
How much will it be given in the thing?
Nothing. Just multiply it. There's nothing to be given.
Like if I multiplied it by like, if it was like 2, let's say it
Yeah.
was 2. The capacitor said
Okay.
on it 2, like number 2. I will get exactly if I multiply, you see here the calculator?
Mm-hmm.
Uh, can you see?
Yeah. Okay.
Right, this, you see this? If it said like,
Yeah.
I said like I had 52, yeah? So where is this
Yeah.
going? 52 ohms, yeah? And multiplied by, let's say the capacitor is 2, I will get what? I will get 104. Bro, on the
Mm-hmm.
capacitor, do I immediately just write 2? If it said on it 2?
Yeah. No. If you see microfarad, then you have to convert it into Faraday.
Yeah, but what if I like if I saw a microfarad on the number, like let's say I was looking at the thing, like I was looking at this here. You see this?
Mm.
You said this charge, yeah, this circle here.
Yeah.
This is number 2 and number 5, and between
Yeah.
them there's a charge and it says a number on it.
Capacitor.
Yeah, it says a number on it. Yeah, on the capacitor.
Yeah.
There's a number on it.
Yeah.
Okay, and that number is like, let's say it gave me 10, 10. What do I do if it gave me 10? 10 by itself without anything. That means what?
Then it's Faraday.
So I just write 10.
Yeah. Just multiply it by 10.
Okay, but what if it said like M10 for example? No, let's say it said M20. What do I do if it says M20?
It wouldn't say M20.
Okay,
It would
M1.
never say M20. It will only say ohm.
Ohm.
For resistance, yeah.
It's either there is ohm or there is nothing. يعني you mean?
Yeah, correct.
So it either could tell me like if it just says number 5, I just multiply it by 5.
Yes.
But if it said ohm 5 or 5 ohms, huh?
What?
Bro, can you just focus with me for a second?
Yeah, I am. Focus.
Yeah, okay, so like let's say we write our resistor, right? 52. We got 52, yeah?
Okay.
And
Okay.
then multiplied by the capacitor. The capacitor, we were looking at it and we saw like the number like 2, for example. We just multiply 52
Okay.
by 2.
Yeah.
Like that, yeah?
Correct.
And then we
Yeah,
get say
correct.
the same number like this.
Correct.
Okay, but what if we wrote it? What if we saw the number and we saw like, so it didn't say 2, it said like 2 with something.
What do you mean?
You said how, so it's always going to be a number, or there needs to be a micro?
No. Sometimes it will show microfarad. So then you have to convert it into Faraday by multiplying by 10 to the power minus 6.
Okay, so if it was like 5 m, will it say 5 micro? How do I know it's
Yes.
micro? It will just say what?
Micro is the mu symbol.
You mean like mu 0 or mu I? What will it say?
No, mu, the symbol. Just type microfarad. It will show up.
This you mean?
Yeah, that's
UF.
symbol.
So if it did
Yeah.
not say UF, I don't need to write anything.
Yeah.
Okay, so I'll just write this down. Okay, so to color and this guy. So if it says like mu f like mu f10, I'll make it what? I'll multiply 10 by what? By 10 power by negative what's it called? 10 by negative 6, yeah?
Yeah.
Then put that multiplied by 52. Then
Hmm.
bro, my time will be weird. It will be like 5.000.
Yeah.
It will be, the time constant will become like 0. Like this 0.00052 like this.
If you do the calculations properly, that won't happen.
Bro, I wrote in the calculator now. I just said, for example, if I got like let's say 52, yeah,
Okay.
multiplied by what? Let's say I got like 2, but it said what? But it said Faraday, right?
No, I would say 1000 microfarad.
It will say 1000.
Yeah.
So
Which
1000.
microfarad?
So I put 1000, then multiplied by negative 6, power of negative 6.
10 to the power minus 6, yes.
Huh?
Yeah, correct. Do it in front of me. Let me see.
I'm like looking at this here because see here, this guy. It's, let's say we check our resistor. How do I get time constant? Is basically my resistor times the capacitor.
Yeah.
And the resistor 52 times, let's say the capacitor was 2, I will get 104 seconds. But let's say the resistor said like 5 what Mao Faraday, which is like microfaraday.
Yeah.
It will become what?
Then multiply it into 10 to the power minus 6. Bro.
So
It's not even
54.
that hard. Why are you
54.
complicating it so much?
No, I'm just because I want to know what to write. There's two cases. I mean, it could be microfaraday and it could be just normal number.
It's mostly always microfarad.
Okay, then if it's microfaraday, what the hell do I do? How do I get 104?
You take the microfarad and you multiply it by 10 to the power minus 6. That's it. Simple.
Okay, I think I need to use scientific calculator to explain to you why it's weird. Scientific calculator. You see my screen?
Yeah, yeah.
Okay. Now let's say 52, yeah, my resistor, yeah.
Okay.
And then you said, let's say we got like what in the capacitor? Like you see the capacitor, this shit here.
Yeah, I know what a capacitor is. Yeah.
Yeah, like this thing, yeah.
Yeah, I
color,
know.
The color coding. This, that, yeah. This, how do you know what is the number? Will it be like? Will it be like shown like this?
Yeah, it's all.
It will be like this, yeah. Micro F.
Yeah.
1000.
Correct.
Okay, if it
Correct.
told me micro F 1000, what do I do? 52 times what? Times
1000
1000 power
into
of what?
into
What do I put into?
into 10 to the power minus 6.
How do I even put power? Right. Can I do this? Yeah, power into what?
No. 1000 multiplied by 10 to the power.
So
Yeah.
it will become like this.
Yeah.
But what about the number here? See, I got on this one, we got like 104.
Hmm.
Hmm?
It doesn't matter.
It does not matter.
Yeah. Then your values will be different. That's it.
Okay.
Yeah.
Because that's that. Okay. Okay, so 52 multiplied by 2 will give you what, like, okay, 52 multiplied by UF 1000, yeah? So UF 1000 multiplied by 10 power of negative 6 is equal to so I put 1000 times 10 power of negative 6. This will give me what, like, for example, 0.052, which is this one. That's it. So my time is on the case for just for charging is this.
Yeah.
0.052, not the 104. And that compute the experimental time using the charging and discharging time constant. This it means like if I put like this guy, but in this case it won't count because we'll only have one of these.
Yeah.
With the values of C and R, the values can be read from the components. What is this? C and R.
This is what I told you.
Hmm?
Most of the time,
Values of C is we don't have a value. 10 times. Yeah, you just said that. Oh. Wait, how did you get a resistor 10 times 10 over? Oh, it depends on our color, yeah?
Yeah.
Okay, and if I got in my color 10, so that means if it's 1, 0, 10 power of 4, that means what? Wait, if I can't do it, it will become what? The first one should be, the first band is brown, brown, and second one has to be what? Black. Black times 10. What's times 10? Brown again. And then what's the gold? Gold, I think, is it?
How do you know the color?
The numbers, you can read them. See? Wait, 1, 0. Wait, how do I calculate this? Wait, is it 1 over 0 times 10? The brown is 10. Power of 4, yeah? What's power of 4?
Yeah.
Which one is power of 4? See, we got here power of 4.
Yeah.
From where is this power of 4? Which one has power of 4?
Look at the yellow, I think.
Yellow, yeah.
Yellow is there.
Yellow is
Yeah.
0.02. Maybe gold. The gold is plus minus.
It doesn't matter in the exam. You'll be given the exam.
Wait,
He'll show that.
1.0 times 10 power of 4. Power of 4 times 1000 times 10 power of negative 6. This gave me exactly 100. So I think we made a mistake here, but it didn't count. If we did that like by the number, how did we even get power of 4, bro? Do you know what color?
I got power 4. It's correct or not?
Huh?
It's correct. Even I got power 4.
But from where power of 4?
The multiplier.
Huh?
For me, I got power 5.
How did we get power of 4? Is it power of 4 just 1000?
No. It's 10,000.
Yellow. Is it because tolerance is no multiplier? 10 times 10 power of 4. The brown should be what? Should be yellow actually. 10 kilo ohms. Okay. Okay, that's that. Then we know how to get our C, which is what the capacitor. We're looking at the capacitor, the colors. Then we'll know, yeah, because it will just
Yeah.
tell us mu 1000, and then if it said mu 1000, that means just 10 power of negative 6, and R is just what is our resistor, which is looking at the color coding. Okay.
Yeah.
That's that. And then what calculate the real value of RC for the circuit? What's the RC for the circuit? It did not tell us for some reason, but okay. So RC real is what? It's just 1000 times. No, it's just R times C again. Oh, that's what I got in the calculator. Bro, then it's different. How do you get time charge? What the fuck? Bro, do you know how to get time charge or no?
What?
Bro, I just the way that we got just now, like R times C, we got this.
Yeah.
We got 100, which is exactly the same as like this.
Yeah, okay, that's good.
But what about this guy? Time constant. How did we get 100?
Yeah, then you have to compare the two values. Percentage error.
Oh. But how did we get 104? That's the weird thing. Plus, I don't even care anymore. Okay. Just
By the graph, I told you.
then it will just say compare experimental time constant and obtained in 7 with the real time constant. So if it says compare this one with this one, we'll just write the experiment, which is our experiment, L experiment minus real over real times 100. So 104 minus 100 over 100 times 100, which is equals 4%, and then if they say discuss, we'll just talk. Then that's the end of that lab. And now this one is not coming. Okay, now this lab. First in a current carrying. I already wrote this code down, so I don't need to watch the video. Okay. Experiment 9. Current carrying. Okay. Hello, you here?
Yeah, I'm here, bro.
Yeah. Let's just finish these last two.
Yeah.
Just give up, خلاص. Okay. So yeah. So I m and delta m and f is equal to hard to think, yeah, to this guy.
Yeah.
And the lab, in that lab, lab 9 force and current carrying, we have a power supply, we have magnetic assembly mass, which is like this mass that you put something in it between, yeah? And then we have our balance, which we like always make it 0 before putting anything. And then we have lenses, and by procedures, it will tell us like what lens to take, yeah? We'll see its number.
Yeah.
Then we put that lens, like we plug it in like that, and we have it's like a table here. Wait, let me draw it quickly. Okay, so clear this whole page. Wait, let me erase it. Okay. You see this shit?
Yeah.
Okay, so first we have a what? We have our power supply, yeah? This is the power
Yeah.
supply, and we have this multimeter next to it, and we have this mechanism, which is like I will just make a just create it quickly, which is like this. What's it called? Yeah. It's like a box, yeah, small box here.
Mhm.
Right now, let me just put it like. How do I increase the size? Yeah, yeah, okay. So this mechanism here is like a box with this type shit here.
Okay.
Wait, let me just draw the mouse thing. This is, where you put the mouse in the middle?
Mhm.
Yeah. You see this shit? This is like where you put the mouse, okay. So now we have our mechanism, this guy. We'll make it what? We'll make this guy go in what? Go here.
Mhm.
Like this. This guy has what? Has like two ports, yeah? It has like port here and port here. I will call this left one. How do I make this
Mhm.
more visible? This port here and a port like on this is left side and right side. Two ports. This
Yeah.
is the wait, this is the fuck, why is this port so weird? Okay. Okay, so this guy is minus and positive here. And this is the multimeter. And this is the thing. We'll use amp, I think. We don't use volts here.
Yeah.
And this is the three stuff here. This
Yeah.
is like the machine, like you just like a mouse, random thing. And then you'll
Yeah.
have your thing. You'll have what? You'll have our mouse here, which is
Mm.
the thing. This drawn like here.
Mm.
You will add like we'll add the thing in the middle of it. This is the mouse here.
Yeah.
Okay. So we'll bring this guy. We'll bring this guy here, yeah.
Yeah.
We'll add it here, yeah, in the middle.
Mm.
And then we'll what? We'll have this guy here. The lenses, yeah, lenses. We'll have like this. This is what like the average lens looks like
Mm.
this. We'll
What
take-
experiment
Huh?
is this?
Huh?
The magnetic force on a current carrying conductor, yeah?
Yeah, yeah,
Magnetic force on a current carrying conductor.
yeah. So we'll take this guy, yeah, here.
Mm.
We'll do what? We'll like make it what go in between. After we plug in the wires, we'll like make them go in between it, yeah.
Yeah.
But first, what do we do? First, now we put our wires. So what's our wiring? It's gonna look like this. First one, we have our amp 1, amp 2, COM and V2. We'll take the comp. Yeah, first we'll take the comp to what? First one, we'll take a negative, yeah? We'll put the negative where? No, wait, let me just draw. We'll put the negative here, yeah? To this guy.
Yeah.
And then we'll take a positive. The positive will go to ampere 1.
Yes.
And then com will go to what? To com here.
Yeah.
Com 1, com 2, com 3. And no, it's not this com, it's com 3. My bad. So this will go to com 3, yeah? Here. To com 1, I mean. And then what? We have only 2 wires, yeah?
Mm.
That's it, yeah, for the wiring, I think.
Yeah, I think that's it.
I have this guy, and this guy, this guy.
Yeah. Good job.
You have only 3 wires? Wait, just want to be sure quickly.
Just watch the video again.
I just want to check the wiring for this.
Yeah.
It's here, yeah? That's not.
Highly recommend all of you switch you up.
Yeah, see? One wire is going to this guy, and then the negative is going where? It's going where?
And replace our magnetic, right? You will have it now fixed. So try to lower it as this is something you should here. Make sure not touching the bit out. So try to be completely. So this is and it goes in
Okay.
there. So from the positive,
Power.
I'll have an ammeter
Positive.
in series, so it
In
goes to
series.
20.
Okay.
And from the COM, it goes to one side of the assembly here,
It will go to the left.
and from the other side,
Yeah.
it goes back to
No, it
the
will be on the right one.
negative of the power supply. That's
So
it.
the current went to this
So I
guy.
just have an ammeter connected in
And the
series to
negative
record
went
what the
to-
current is.
You see the negative went here. That's it. Okay. See? So and then after here, this is I'm lost after this. Okay. And then here he just keeps on talking and like keeps on saying switching and putting them. Okay. So this is our thing for now for that lab.
Hmm.
Just I think now.
So it's correct?
Okay. Huh?
Is it correct?
What do you mean is it correct?
What you did, was it correct?
Yeah, the same exponent, but he keeps on like changing them after, you know, after like every point, like procedure says what procedure says. Take this guy, which is like here, and like take the different lenses, you know. You see this lens?
Yeah.
Oh, the fuck?
Yeah.
Like this lens here. Just take it and like there's different types, you know. There's the big one, another like similar one. I don't know. Like take more and then keep on putting. Okay, that's the.
Yeah, okay.
thing. I think that's good, wallah. Good drawing.
Mm.
Okay. I wish I studied for this last week, not today.
Mm-hmm.
I always study before the exam, by the way. That's my fucking fault.
Yeah.
Okay. But this counts as 3 days, you know. Okay. So F1, what do I write for first one? It's 2 parts. Yeah? Will you do 2 parts in the exam or only 1 part?
Only one part.
And it's not that long too.
But they might ask anything, so you should be ready.
Huh?
They could ask any part.
You're right. Yeah. Okay, so but if you want to get second part, you have to do